Biology, Mr. Petit.
Yes, ma'am, I do. All right, so the recording has begun. This is the Mother's Day special, they say. Um, Sunday, the 8th of May. On a Sunday, we are hitting it hard, trying to get the maths in. Um, and so what I'm going to start off with is we're just going to try as much as possible to get as much paper threes in today. So I'm going to start with
That's the last paper, right?
last paper. Yeah, that's the last one. That's where most of the problems usually should be. Um, with a lot of students, there are problems with paper three. That's usually the issue. I'm gonna begin with 2018 paper three. Um, and and so let's begin. So I'm going to start off with this first question. This is an interesting question. You have to think for this question, to be honest. It says value added tax of 7.5% is added to the purchase price of consumer goods. The total price of the wristwatch is $96.75, and the question states, calculate the price of the wristwatch before we add VAT on. Very, very interesting question. So they're asking you, before we add before we add VAT, excuse me, what was the price?
So first we have to find 7.5% of 96.75, and then take that away from 96.75 to get
9675.
the original.
No, never. I wouldn't wait.
Okay, wait. So my question is, to be clear, 7.5 is already in that itself?
Mm-hmm. The VAT is already added here.
Oh, okay.
Mm-hmm.
So would we put 7.5 over 100 and then times it
No.
to, we wouldn't times it by that, times it by 97.75, and then when we get we'll get the added tax price, and then we just can't take it away.
No, that wouldn't work.
Mr. Badi,
That's too much working.
That wouldn't work.
You think so?
That wouldn't work.
Why wouldn't it work?
Because
Why? But that's how
because
I do it. Sorry.
let me tell you why. Because um this is the price with the tax already on. So you need to figure out what was the original price. So the 7.5% is gonna be of something.
Okay,
It's
I see what you
of
can.
it's of the
I see
original
what you
price.
mean. I see what you
Then
mean.
we add that VAT to the original price. Then we get the 96.75.
So
One
would
more.
we
One
would
more.
we put 7.5 over 96?
Mr. Badi,
Yes, sir.
how about we divide $96.75 by 7.5?
No. No. Definitely no.
Multiply? Can we multiply
So
it?
we
No.
can
That's
we can
more.
directly use these two values. Then that's what you're saying.
Can we turn it into decimal and then multiply? I
Multiply.
think I just trying to figure out. I didn't know that was even. So I always used to get that question wrong then, because that's what I used to do.
This is a very important question. It ain't as straightforward as we think. But there's a way we can do it. Right?
What?
There's a way to do it. So I don't want to waste too much time in us thinking about it. I'm just gonna go directly to the answer and then just explain it as we go so that it wouldn't take too long. Um, so I'm gonna start with the equation. I use an equation for this. So I say let x be equal to the amount of the wristwatch before the VAT is added. So x is what we're looking for, the amount of the wristwatch before we add VAT. We call that x. We agree? You understand that, right?
Because it's unknown.
It's unknown, yeah. If that's the truth, if that's x, right, then the following computations must be true. And that is 0.075x plus x equals to 96.75. Once you understand this, I think we could. 0.075x plus x must be 96.75. Do we understand why I do this?
So you're
No.
saying 7.5% of X
Mm-hmm.
plus
X.
Plus the
plus the
original price.
original value
So you solve it
is
like an
equal to this
equation.
new value.
Yes. You see that? So we don't know what the original price is, but if we knew what the original price is, we'd take 7.5% of it. That's this right here. This is the VAT right here. This part is the VAT, right? Because that's how we calculate VAT, don't we? We do 0.075 times X times the original price, don't we? Don't we?
Well, not recently, now it's 12.5.
I mean, for VAT
I'm
in
trying to understand. So they do solve it like an equation, basically.
I'm solving the equation to find X, the
Mm.
original price. And so what I'm saying is this is VAT. This right here.
Why add X though to?
Okay, because X is my original price. After I find what the VAT.
No, I mean X as in 0.075.
Say it again.
Why add Wait, why add X if
Uh-huh.
to 775? And then when you do this in a decimal point, is it supposed to be 0.075?
Yes.
Not 7.5x?
No, Nancy. Okay.
You gotta break this
Okay, what I'm
down.
trying to say is right? Let's say that sorry. What I'm trying to say is what I'm gonna do is I'm going to give you all the answer, right? And then I'm gonna show you why this equation makes sense so you can understand. So the answer is 90. The original price is 90. All right, that's the answer. And I'm gonna show you why that would be the answer. Okay. So remember, we go to the shop. We find that this wrist was on sale for $90, right? But we need to figure what is VAT of that, right? Because they're gonna add VAT to that, and VAT is gonna be 0.75% of what? The $90, right?
Yes, sir.
0.75% of that $90 is 7.5 divided by what?
100.
100. We're gonna multiply that by what?
90.
over 1, right? Which is going to be 7.5 divided by 100 is going to be 0.075 multiplied by 90. And then once I do that, right, I am going to get 6.75. This is going to be my VAT. Now, what am I going to do to this VAT to find the total price?
Add it.
Exactly. So for total price, I'm going to take 6.75 and then I'm going to add it to what?
To the total price.
To not the total price.
90.
The original price, 90.
It's not again 90.
And that's going to give me what?
96.75.
Good. 96.75. So what the question is saying, right? It's saying pretend as if you do not know what 90 is. You don't know what the original price is. So pretend like you don't know what this is. How would you figure out what this is going to be if you don't know what it is? Right? All you know is that the final answer is 96.75, right? And so we know it's clear, right? The total price is going to be what? The total price is going to be 96.75. That's the total price. But the way how we got the total price, we had to add what? The 90, right?
Yeah.
But remember, we don't know it's 90, so we can call it
X.
X. Very good. Plus what?
plus 0.075.
Wait, plus 6.75, right?
Yeah, but isn't it 0?
But 6.75 is what?
0.075.
That's 0.075 times what?
Huh?
Times what? 0.75 times what?
100
Times what?
times 90.
Times
What?
90. What is 90?
90 is x, right?
Very good. 90 is x because we don't know what it is. So we working backwards. We pretending like we don't know what it
So
is.
that's why you put x there.
Yeah, that's why I put x there.
But you had plus x, so
No, that's why I had 0.75x plus x.
why is there two x's?
Because remember, this first x is it. Look at this. Look at this part right there. Right? This first x is for the 90. You agree?
Uh-huh.
Good. This second x is going to be, remember the 6.75? The way
Yes.
how we got that was we multiplied 0.75 times 90.
Yes, sir.
So that's where the second x is going to come from.
Ah, okay.
You see that?
Starting to make some sense in my head.
So what we had to do was that we had to first find the VAT, right? And then after which is 0.75 of the original price. Then we had to add it to the what? Original price. Then we're gonna get the what? The total price. You see that?
Okay.
All right. Anyone have any questions on this? Please speak.
Hey, good day. We could do an next one so I could fully understand it.
Okay. No
Mr.
problem.
D,
Yes, sir. We could do an
can
next.
you go back on question, please, so I can write it down?
No problem. We could go back. We could go back. Sorry. We could do another example. Um, but anyone else need help with the equation and how we got the equation? Okay. So now that we have the equation, so we have to pretend like we didn't notice, right? And only work with the equation, all right? Because here, remember, I say I'm gonna give you all the answer first, and then from the answer tell you all the equation. Now we're gonna fully work from our equation because we're gonna pretend like we didn't know the 90 was there.
All right.
Okay, and so thus, when we go back here, we have um that my apologies. We have 0.05 x plus x. When we add these two, we get what?
So wait, the x represent a 1 now?
No, remember, we add them. So this is 1x plus 0.075x. So when we add them, we get 1.075x.
So what? So x is basically just saying 1.
This is 1. The coefficient is 1.
Wow. That's powerful.
This ain't new though. We know that. We know
Mr.
that.
D,
Yes, sir.
so we have to convert the percentage to a decimal at all times?
You don't have to at all times. Just in this question, it's more convenient to write it like as a decimal so that we could add the 1 and the 0.075. Okay. So we have 1.075x plus, equals to 96.75. Then what I gonna do? I solving for x, right? And so I wanna cancel out both. That's gonna be equal to 96.75 divided by 1.075. Then I divide the two and I get 90. So the original price before VAT, is $90. All right. And if I do 7.5% of 90, right? And I add it to $90, I will get 96.75. And so you have to be careful. They're asking you for the price before.
I have a question on this, right?
Yes, sir.
So knowing this, would you go ahead and just put a 1 before the percentage always, and just do the end product?
Okay, so knowing this, a short way would just be to take the total price and divide it by 1.75. That's all you need to do.
Yeah, like would you just put 1 in front of it and then do the percentage?
What do you mean?
Like let's go back to the question: value added tax 7.5%.
Uh-huh.
What's the total? What's the price of the risk one before? Like
Yeah.
so, I could take this 7.5 and put 1 before it
Yes.
automatically.
Yes, automatically. Yeah, automatically.
Yeah, like would that be universal if that was like 75%?
No, now for 75%, all you need to do is convert the 75% into a decimal, then add 1.
Yeah, so that 1 ain't never changing.
No, that ain't changing.
Okay.
No.
Can we practice
Just
one
press
if that's okay?
Yeah, sure. Let's do another one. So,
Just like a grasp it.
yeah,
Hold on, Mr. Petit.
no problem.
Mr. Petit, before you leave, you see how you have 0.07. So why is the answer 1.075?
Okay, because if technically this is actually a 1 in front of the x.
Oh,
Okay.
okay.
So maybe I should have put that a. Okay.
No, I was thinking that, but I said I don't know. I just come so.
Yeah, so it's 1 plus 1.0, 1 plus 0.75, and that's how we get the
Oh,
1.075. Yeah. Okay.
and welcome.
Yes, welcome, Miss
you.
Future doctor, y'all. Future doctor. I believe.
What type?
Neuroscience.
Congratulations.
Cardiothoracic surgery.
Okay.
Okay, big shot.
I know, right?
I gotta get maths down though. I gotta learn.
Child, I ain't even good at how you
I have
being a
to be
doctor. Okay.
good at maths to accomplish that goal.
I wish you all the best.
Certainly.
Yeah, all the best. I ain't trying to go that far.
Ah, man. Boy, you.
All I would do is just go in the sports industry and medicine, and that's me.
Oh, yeah, you did say that. Oh, that's 2 doctors, eh? All right, so let's add. Let's do the next question. So,
Hold on, Mr. Petit.
you can take a screenshot, because we can be doing a lot. I don't want you to write.
You will go.
Yeah. Okay, so let's do another question. So value added tax.
Also, the 1 would always be in front of the decimal, right?
Yeah. 7.5. I can keep it at 7.5%. Is added to the purchase of, let's say, hand buys. No. Purchase of, let's say, um, auto mm, licenses. Right? The total price of
We writing this?
just focus on the thing on the. You could write or take a screenshot, but I don't want to take too much time with you writing. But I want you to actually do the problem on your own. That's what I'm saying. The total price of Mr. Bethel's driver's license was is $53.75. Calculate the price of the license before value added tax is added on. All right, so try that on your own. 60 seconds should be enough. So let me put the time on. $45 more seconds.
Could we get a little more time, please? I can't find my calculator. Hold on.
30 more seconds.
You going 50?
You going with 50?
$50. I agree.
You go with 50? And
I so lost. It's deep.
okay, no problem. That's fine. That happens. Okay, so
Hello, you to hear me?
yeah, I hear you. I hear your answers. Okay, so remember. Okay, so remember for this one. So the answer is 50. We know the answer is 50, right? But I am going to work with the idea that the answer is 50, just to show you how we could work backwards, right? So remember, in the exam, you wouldn't know the answer is 50, obviously, right? But just so you could understand what's happening, I'm just gonna tell you the answer first and then show you why it's 50, and then we could use X. So remember, VAT is added to original price. Always remember that. VAT added on. So 7.5% is going to be added to an original price, which is what?
$53.
No, not 53. This is the price after you already added.
Okay.
You see what I'm saying? So the 7.5 is going to be added to the 50 first. You see what I'm saying? So it's going to be 7.5% of 50, which is 7.5 divided by what? 100. You agree?
Yeah.
We're going to multiply that by 50, right? When we get that, this is going to be equal to 0.075 multiplied by what?
50.
50, very good. Which is going to be equal to what? 3.75. Okay. Now, if you want to figure out the total price of this license, it's going to be what? The total price.
You add that to $50.
Very good. So it's going
You
to
add
be
the answer to $50.
very good. It's going to be 3.75 plus $50. Okay. And that's going to give us the answer of $53.75. Now, this is when we know that the answer is 50, right? But the question says, how you know it's 50 before? You see what I'm saying? And so we're gonna and every time we see 50, we're gonna place X. Because remember, the only reason why we know it's 50 is because, I told you it's 50, right? But if you're in the exam, you ain't gonna know it's 50. You got to use algebra to figure out it's 50 or 90 or whatever. And so
But
wherever,
remember, T,
yes, sir.
we can't just use like the hack and just say 53.75 divided by 1.075.
Yeah, that's the half. That's the half. Yeah, that's the half. Yeah, that's the half. That's no problem. We can do that. Yeah.
Can you show me how you got 50, please?
Yeah, I'm gonna show you right now. So notice that here we know it's 50. So everywhere I see 50, I'm gonna highlight it, right? And so what 50 basically is, 50 is our x, right? That's what 50 is. So 50 is what we don't know. Okay? So it's gonna be x plus what? So it's gonna be equal to $53 and what? 75 cents. How did we get to $53.75? We took 50, right? Which is x. We added it to what?
$3.
With
We
7
added,
7.1.
we added to what? 3.75.
3.75.
Yeah. But what is 3.75?
0.075, eh?
That's
7.5% of 50.
exactly. That's 0.75 times what?
It's
50.
50.
Yeah, you see that right? So 3.75 is exactly 0.75 times 50. So instead of writing 3.75, I'm going to write 0.75 times what? I can't write 50. I have to write what? Times x. Okay? And good. So now I have my equation. So now I know that what? This is 1. So it's going to be 1 plus 0.75, which is what? 1.075x. That's going to be equal to what? 53.75. And it's going to be equal to, but I can divide both sides by what?
1.075.
Yeah, 1.075 minus 1.0. And so you're going to cancel this out, cancel that out. And so you're going to be left with what? X is equal to, what is $53.75 divided by 1.075?
Should be 50.
That's 50. Okay. So the secret to answering this question is that whenever they give you something like this, notice that all we're doing is dividing the total, right, by 1.075. That's all we're doing. So if you don't want to go through all of this algebra, just take the total and divide it by 1.075. And that will work. Now you got to be careful because if they change the percentage, right, like say for example, they change the percentage to say 12.5%. All you need to do is change that to a decimal, and so it'll be what?
1
0.
point
0.1.
125.
Say it again.
0.
1.125.
Say it again. I mean 12.5%.
Okay, 0.125.
0.1.
What is 0? Down
12%.
here?
12.5% is 0.125.
Oh.
Because you divide that by 100. That's all you do.
Yeah. I understand. I just was trying to figure this.
So,
I just didn't know that by hand.
oh, okay. And so 12.5% is 0.125. So if I say it's changed to 7.5%, all you need to do is add 1 to it. There's going to be 1.125 to that. And then divide that by what? By the price that the total price that they give you. Okay. So basically all it is taking this price and dividing it by what? By 1.75 or 1.125 or 1.15 if it's 15, or 1.17 if it's 17, or 1.18 if it's 18%, or 1.19 if it's 19%, or 1.2 if it's 20%. You understand what I'm saying? Just divide this by 1 point whatever the percentage they give you. Do you understand that? Or no?
I think so.
Anyone else? Anyone else?
So in that case, we would always put 1
Always put
and
one.
free.
Always put one in the front. Always put one in the front. Because remember,
So make it
whatever,
like a rule then.
that's a rule, yeah. So whatever, remember,
Okay.
if you end up adding them anyway. I'm just trying to save you from the algebra. Right? You end up adding them anyway. Like, one always stays. That don't change. It's just your percentage might change depending on what they give you. So if they give you 7.5%, just add that to 1 and then divide it by whatever total amount they give you. If they give you 3.5%, add it to 1 and then divide it by whatever answer they give you. So let's try that. So for this one, I'm just going to give you the final answer and then the percentage. So if I say, let's say we try and do it for not a watch, but this time a suit. All right, so let's say the total price for the suit. So total price. Say that the total price for the suit is, this is with VAT added now. So the total price of the suit is, say, $75 and let's say 35 cents. And so, and I say that the VAT percentage is, say, 3.5%. So what's gonna be the original price? Tell me what we're gonna do.
Um. So what we're going to do is we're going to convert 3.75 into a decimal, which would be 0.035.
0.035.
And then do the shortcut way or do the long? Okay, so just add 1 and then automatically you get 1.035 equals 75.35.
We're gonna put on top.
That's not the way I did it. Sorry.
75.35.
Yeah, 75.
And then you get your answer from there.
Okay. So the answer would be that it was $72.80. Okay. What if I say if the total price was $85, let's say $86 and 30
This
cents.
would be.
Yes, sir.
They would ever ask you like, what is the original price when it was on a 20% off sale?
20% off sale. 20%.
Yeah, like before VAT, and it was on a 20% off sale.
That's I have never seen a question like that, but that isn't without our reach, because just a matter of adding the X and taking away the X, and or just adding the percentage to the thing. It boils back to this formula. But I haven't seen.
So you just get like to this point, like you would just find out what X is, and then just get 20% of the X, and that would be the original.
You would
from
say
there.
because if you want the discount, so the discount is going to be 20%. So 20% is going to be as a decimal. We divide that by 100, and so that's going to be 0.2. And so that 0.2 times x, then you're going to take that away though. You can't add it. So you're going to take it away from the one.
Yeah.
And then when you take that away from the one, if you have value added tax again, you have to add the tax again. So it's going to be 0.075x minus 0.2 plus 1x. You see what I'm saying? And that's how you would do it.
All right.
Yeah. But anyway, back to this one. So the total price is 86.37. The VAT is, let's say the VAT is 12.5%, like how it is now. All right. And I want the original price. Okay, so what would the original price be?
Pardon me?
What would the original price be? The
Oh, 1
It would be
1.125
77 cents.
I want the formula first. I
over
want the yeah 1.1
Okay.
75 plus
over what?
86,
Over what?
86,
Uh-huh.
35
35 or 30.
equals, 37, sorry, equals to what Mr. Bethel just said.
So 86.
That's that.
Yeah, that's it. 86.37 divided by 1.125 to $76 and
77 cents.
77 cents. Okay, so that's what we do.
I mean, I thought it was like more third, but once you get the hang of it, it's pretty easy.
Yeah,
Yeah, this is a shortcut way.
there's a shortcut way. we eliminate that.
So both ways work. The
Yeah,
bottom and the top.
this is the same thing, we just reduce to the part that really matters. Like, because if you look at what we had before, all we basically did really was divide 96 by the 1.075. That's all we really did. You know what I mean? And so Berthold was like, okay, well, just take that part and use that. You know what I mean? But
Yeah, I realized that one was the constant. So
yeah, that's what we use in our answer in our question. You know what I mean? And so that's the way. That's why it's only for 2 marks. You know what I mean? But I did all this just because I wanted to be, you know, a mathematician. But
the completeness.
yeah, for completeness. That's the word, for completeness. Um, so all we basically doing is taking the total price, dividing it by 1 plus the percentage. That's it. Okay, we good?
I'd say so.
Anyone else? Are we good?
Yes, sir.
Good stuff. Okay, so moving right along. Next question. Matrices. Love it. For the matrices L and M, calculate the matrix product. So it's going to be LM and ML. I want everyone to do it for me, please. Calculate the matrix product. You have 60 seconds on the clock. Let me do the matrix product for this. So there we go. 60 seconds. We want LM and ML. 45 seconds. So we multiplying these two matrices. The first one is L, 7, 0, -3, and 3. -1 and 3 rather. And the second one is 2 and -5. 30 seconds.
Mr. Petit, can we get more time, please?
Okay, okay, okay. Got it.
Okay.
All right, that's time. Go ahead, Mr. Doctor.
I may be wrong, but I don't care. 14, 0. And then on a second row is -2, -15.
-2 and -15. Okay. Anyone else?
Aren't we supposed to add them to get a finished product? Because I got the same thing, but aren't we supposed to add them to get a finished product?
You should.
So it's gonna be 14, and then you add the last two bottom.
Yes.
Okay. So I get -17, but I scared, man, because the thing bitch freaked me out. Like you would have the plus and the negative. I'm gonna lock in
Okay,
-17.
okay, you can lock
I'm
that
gonna
in.
lock that in.
What you got for the second one?
What you mean?
B. Because A and B.
Oh, I do B. I do A.
No, no, see. Quickly do B.
I tell you, I need more time.
Anyone else put A and B?
I only
Ricardo,
got A. I
Alicia.
only got A. I have to be right now. Hold on. I got B.
Let's go, Ricardo. One hand from you. One. One hand from you, Ida. And Alicia. What y'all get?
Yeah, maybe the -17 for true, because the matrix should be 2 by 1. So I guess you gotta add them.
Mm.
Hold on. So when you get your answer from multiplying, what are you adding?
You're going to add the results that you got. Add them together. Add them too.
For B, I got 14, 0, -2, -15.
Okay. All right. One. One hand from you, man. Ricardo. One hand from you, Ida. What happening? Say something. Let me know what's happening.
I said Reagan.
Still working. Okay. All right. Ricardo. Ricardo, you here? What's up?
Already, y'all.
Yeah, what's up?
Still doing it.
Still doing it? And you might not in this exam only a few moments long. So you can't spend so much time on one question, right? Um, so let's do it. So remember that we have L and M, and so for this one, we're going to first multiply the 7 by the 2. That's where we get 7 times 2. And then we're going to say 0 times -5. That's why we get the 0 times -5. And then we're going to add them two together. Okay? Then the next part is that we take the -1 and the 2, right? And then the 3 and the -5. Then we add them together. Okay? So that's why we have 7 times 2 is 14. 0 times -5 is 0. And -1 times 2 is -2. And 3 times -5 is -15. And so what that end up being is that you end up having 14 plus 0, which is 14, and -2 and -15, because a positive and a negative is indeed a negative. So this end up really being negative 15. And so this is negative 15 and negative 2, and that'll give us negative 17. So for the first one, we have 14 and negative 17.
First time I get that right, eh? Mud just I feel like a bag of quarters. No, because the first time I actually get it right.
Wow, that's good. Any questions from anyone else?
I was a little slow with it, but all right.
Okay, all right.
I agree. That's the first time I feel like I do something way on.
Okay, all right, I like that.
Yeah, this one makes sense now, like for real.
All right, so let's do B. Now, B, as we all know, is undefined. I don't know
No
how.
way.
I don't know how y'all get. I don't
No
know. I don't
way.
know how y'all get trapped into
I didn't even
multiplying that.
I didn't even thought about
Like clearly is 1 point. That's the first thing, right?
I
Clearly,
didn't even thought about oh wow.
clearly,
No way,
right?
boy.
That's the first thing, right?
That's the thing.
Okay.
I wasn't gonna answer B, I was thinking of it if I leave it blank, but I still get it right.
You could leave that blank and get it right here.
No,
Well mother said
no,
So you have to write undefined.
you have to say undefined.
Miss Uti, I do a whole calculation. You couldn't tell me I wasn't tripping out.
No, I that's why when Bethel says answer, I just say okay. Then Nancy follows suit.
No. I said my answer for the first one.
No. You said your answer for B2.
No, that was for the first one.
No,
I just forgot to add it.
I didn't
I could have
multiply.
sworn you said your answer for B.
No, we didn't. He didn't say that. It's only me who said something.
No,
Wow.
they was on the next level with B. I didn't know how to approach that.
Oh, you only approach.
Mr. But I didn't even do the multiplication thing to realize that though. I just got you
Yes,
into
you
multiplying
always do
it.
that. Remember, you always figure out. Remember, before you multiply the things,
You had to call him right. Oh
you
my
always
gosh.
see if the criteria is right. So remember for these, right? We always check first to see if the criteria is right. So what I mean is, for example, so this is going to be um, so this is what. So remember, order matters. So L times M. We're gonna look at the L this order for us. So it's gonna be 2 by what? 2, and then this is gonna be what? 2 by
1.
1. So that's why we could multiply these two.
I didn't even do that. Not do.
So that's why we could do this. But the moment we switch it, M and L, we end up having what? 2 times 1, and what? 2 times 2, and then you realize that hey, these two are not the same.
Yeah. Just realizing that.
And the thing is, I was like, man, I was like, what's the big hint is that that thing only for 1 point.
No, Mr. Petit, honestly, I really thought
That's the
I
biggest
was
hint.
multiplying that thing, man.
That's the biggest hint. So
Don't worry, we ain't get it next time.
yes, I really hope. Okay, good. So I'm moving right along. Okay, let's go. All right, so the diagram shows a slice of cake cut from a large cylindrical shaped cake. The cake is of radius 10.5 centimeters and thickness of 3 centimeters. The cross section of the slice is a sect of the circle, making an angle of 60 degrees at the center. The first question says, taking pi as 22 over 7, calculate the volume of the slice of the cake. 3 points. Any ideas on how we're going to do it?
A?
Yeah, A.
Can I see the question?
Yeah, that's there. Calculate the volume of the slice of cake.
Oh, volume.
Volume, yes.
Volume. The formula for volume is on the. Can we look at the formula for volume? I don't remember it on my head.
Volume of what?
A cylinder.
Is this really a cylinder?
Mm.
Or it's a
Cylindrical shape.
it's a portion of a cylinder. It's not a cylinder, right?
So like, what we would like cut it into four or something?
So they it's a section of it, right? Of the cake. So we even if we have I know the let's go back to it. Let's go and look at the formula sheet, right? The formula sheet will help you because I'm tell you why. It would help you to get the understanding of what you're doing. So let's go to the formula sheet, right? So the formula sheet, let's go for it for volume, right? If you look at the formula for volume, where are we? Volume of cylinder, right? So this cylinder, this is the volume of the cylinder. The volume of the cylinder is going to be equal to pi r squared, which is what? What is pi r squared?
22/7.
No, that's area of a circle, right?
Yes, sir.
Uh-huh.
Pi r. Sorry.
Pi r squared is area of a circle times h, right? So the area of a cylinder, and in fact, if we look carefully, it should be somewhere here. If we look at for any prism, the area is going to be the area of the cross section, right? Multiplied by the length. This is the formula that we use in general um, for 3D shapes. So you look at the area of the cross section and you multiply it by the length or the height, right? And so when we go back to our question, right? In order to find the volume of this cake, we first have to find number one, the area of its cross section, and the cross section of this slice of cake is the same top part, the same top part, and this top part is the sector of a circle. Is that what they say? The cross section of the slice is the sector of a circle. So in order to find the volume of the slice of cake, the volume of the slice of cake is going to be equal to the cross section. I hope I write that down. The cross section, the area of the cross section of the slice, times the thickness. So you're going to take this area right here, that sector of the circle, and then you're going to multiply it by the thickness. And it makes sense because if you take each one of these slices and stack them one on the other, 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 that would essentially be the volume um, of this object. So first you need to find the area of the cross section, then multiply it by the thickness of this piece of slice. So what is the area of the cross section, right? This is a what? A sector of a circle. So we need to figure out what is the area for a sector of a circle. And the formula for area of a sector of a circle is you're going to take the angle theta, the given angle, divided by 360 and multiply it by the area of the entire circle. So again, the area for a section, any section of a circle, or any sector rather of a circle, is going to be theta, how much degrees is out, divided by 360, multiplied by pi r squared. Okay? We still multiplying by the thickness doesn't change. So what is theta in this case? Theta is going to be what? Theta is the angle that is um that is here. So that's gonna be what? 60 degrees, right? Divided by 360. What is pi in this question?
22. What's that?
22/7, like they say. What is r?
10.5 centimeters.
10.5.
5.
They say that they tell us that in the question, right? The radius is what? 10.5 centimeters. And then the thickness is how much?
3 centimeters.
3 centimeters. And so we have the part in blue, which is the area of the cross section, and when I multiplied them together, all this part in blue, I got 55.57 rather 0.75 centimeters, and then I multiplied by the thickness to give me the volume of
Mr.
my
Petit,
sector. Yes, sir. My
these
sector.
questions, I mean, that's on paper 3.
What, you wanted to be on paper two?
No, I asked it. It's on paper 3 or paper 2.
Paper three.
Paper 3.
Yeah. Why? What happened?
Hard.
I,
You know my question.
I, I,
My answer. My
know.
response.
I figured. Yeah.
Times
That's
where
too much work, Mr. Bati.
You ain't playing with Joel.
where did 60 come from again? Sorry.
60. Okay, so the 60 comes from the angle.
60.
The 60 comes from the angle. Because remember, if you look at if
I
you look
mean
at
the 60 over 360.
okay, the 360 is a part of the formula for area of a sector of a circle. So the
Oh,
part in blue, that's the formula for area of any sector of a circle. So any sector of a circle that you get, so for example, here we have a sector of a circle right now. That's the cross section of the slice of the cake, right? That is the area of the sector of a circle. And the sector of a circle, when we say sector of a circle, I don't know if you know what I mean by that. The sector of a circle is basically when you have a circle and you have like here and here, that is a sector of a circle right here. So the same V-looking slice, that's the sector of a circle. And then the angle theta is this. So given any circle, if you want to find the area of this sector, it's going to be theta divided by 360 multiplied by pi r squared. Okay, you understand that?
What about the thickness?
The thickness is given.
No,
So
I mean if this the formula you have to add the thickness to.
no, not for area of a sector. No, because remember, you would never know thickness for a circle. It's a 2D shape, so it's not three-dimensional. But here, because this is three-dimensional, we have to add that third dimension, which is the um, thickness. Okay, and so that's why for this one we have um, theta over 360 multiplied by 22 over 7 times 10.5 centimeters squared. And notice that once I finish with it, I keep the centimeters squared and I multiply it by the thickness. Okay, so keep that in mind. Any other questions for me? Let me know.
When we taking a break,
We have any more questions like this?
Just like this?
Yeah, or similar.
Similar. Offhand, no, but there is.
you could just change the variables.
We could change the numbers. There is there's actually a YouTube video that I saw that did a really good job at this. I don't really go to YouTube, so just go on area of not area volume of cylindrical. I just keep it a cylindrical. I don't say nothing. They usually have it. I go on images and I saw something very nice that they had. I hope I could find it again. Um, I don't know if I used. I don't know if I put cake. I don't know if I put cake in there. I can't remember. Okay, good. No man, not in it. That's the same thing. No, we don't want that. Not cake. Area. Oh. I think it might be. Area of sector of circle. I guess I could say GCSE. Maybe I'll wait. I can't remember the site. I can't remember, but he did a good job at it. This isn't just the one, the area bisect of a circle, but I want the one. Okay, this is a good one. This is a good one. But no, this one too. I'll have to send you the video, Mr. Ricardo. Remind me to send you the video of where you get a further practice. But he did do a good job at that one. Yeah. But offhand, no, I don't have a set of questions. Okay, so there we go. Okay, so I realized when I was making this that these questions was long, and so I couldn't squeeze two questions on one paper. And so I said, you know what, let me just make use of the bottom, and so I just made a motivational corner here. And so speaking of a break, we can have a break for the motivational corner. How fitting, right? It says,
Ain't no ways.
who's gonna read it for me? I wanna read it. Who's gonna be my reader?
I give you that.
Go ahead, read it. One.
The heights by great men reached and kept were not attained by sudden flight, but they, while their companions slept, were toiling upward in the night. Henry Wadsworth Longfellow.
Okay.
You could have gave some more life into that, man.
I was trying to figure out
What
what
that
did it say real?
mean? What that mean?
What you mean?
What he
You
trying?
know what that means? You know
What he
exactly.
trying to
You know
say?
exactly what that means. I ain't gotta explain that.
What is he trying to say?
You know exactly what he tried to say.
No, I'm not. I don't know what he trying to say for you.
You gotta. You want.
I see.
You want to explain that to everyone can explain that.
I mean the heights
The
by
height.
great men reached and kept
Listen, see, that too strong, man.
That's just.
Uh huh.
were
Finish
not
it. Mr.
attained by
Finisher.
sudden flight.
That's
Wow, man. Wow, you just
yes, yes.
It's only me who's still trying to figure it out. Wow.
No, man, you don't understand it, Nancy.
No.
Yes, he is saying that the heights that people reach, the
Uh huh.
greatness and excellence, they didn't
Mhm.
get it in one day.
Mhm.
It was not attained by sudden flight. So how did they
Mhm.
get it? While their companions were sleeping,
Mhm.
they were working.
Mhm.
They were toiling.
That's it.
Yes.
So it mean what it say? I thought it was meaning something behind it, like a secret behind it.
No, he's straightforward. All right. So outwork
Wow.
everyone. Okay, let's go. That's enough of the break. All right. Solve the following equation. This is what I live by. Solve the following equation for y, given your answer in scientific notation. So here we have this formula, sorry, this equation, and we want to solve for y. How do we do that?
Pretty much.
Would we basically wait, this is minus y?
Yes, that's minus. That's not negative y now.
Minus y.
No,
Why does do that to people?
that's not minus y. If it was minus y, it would have been
So what is the y connected to?
the y is connected to this bracket.
So we multiply. That's even worse. Can you multiply all of that by y?
Multiply everything by y.
No, the one where y would connect it to y.
You wanna multiply this by y?
Yeah.
Why?
So I could divide both sides. I mean divide it. So I could just get y by itself. I was trying to get y by itself.
You're trying to get y by
Um,
itself. That's a good thing you're trying to do.
yeah, and then I could carry this over,
You want to carry this
and
over?
then I just trying to find a way to do it, like, because it's 4 points. I know it's something technical to it. So either I multiply this by y and then try again and then divide it to get y by itself, or I could carry over and then still divide all 1.1 times 10 over 16 over y, so I can get y by itself, and I'll just solve the other side.
Okay, so you're trying to say send this over.
I think so. But I don't know if it's connected. That's what I'm asking.
No, I mean if you it's just like if you have numbers. So if you have 5x plus 10.
Yeah, so I'll carry it over if it's not connected. Then I carry it over,
Yeah.
and then I'll still divide to get y by itself.
And exactly, and then divide to get y. Very good, Cooper.
What in the world?
I can let it in.
Cooper really miss us. Oh my gosh, she miss us. Cooper miss us. It's okay.
Hey, Miss Cooper.
That's the thing. I just had to join to see if y'all actually to come on.
Yes, we did. We're here. We've been here from what 2:30.
Had to be nosy. I was surprised.
Wow. Yeah, man. Eavesdropping.
Cooper, you came for
Yeah,
fun?
I just had to come see. I just had to come.
Yes, we are. We was waiting.
You really came for fun?
Yeah.
Girl, she's so excited about education. This is the first.
Yes, she's excited.
And now that she here, you gotta ask her the same question you asked us, Mr. T.
What? Oh, Miss Cooper, what did you do for your mother on this day?
I tell her Happy Mother's Day.
That's it?
Yeah.
Yeah, right. No kisses, no nothing.
I cooked the bread
You
on
cook the
it.
breakfast? Okay. That's nice. Honor thy father and thy mother, for thy days may be long.
Amen.
All right, so let's move forward. So, like you said, Miss Nancy, we're gonna send it over. So the first thing we're gonna do.
That makes sense?
That makes sense. We're gonna send we're gonna send this over. Okay. So when we send this over now, okay, watch carefully. When we send this over, it's gonna move from negative and become a
Positive.
positive. See that?
So we sending it over to get y by itself, right?
Yes, we're trying to get y by itself.
Solve for y.
Good, exactly. We're trying to solve for y. Now these two, I ain't bothered to do nothing with them. I just leave it. I ain't change nothing. I just leave it as is. Right? I don't want to bother with that yet. I just trying to get y by itself. Then whatever on the side I could deal with it. You know what I mean? I'm just trying to get y by itself. So after I do it, then I divide both sides by what? This whole thing.
Mm-hmm.
I trying to get y by itself. Okay. So once I do that, I divide this side by 1.1 times 10 to the negative 6. And I have to do the same thing to this side. 1.1 times 10 to the negative 6. Right, you with me?
A lot of stuff going on in this question, Mr. T.
But you with me with dividing both sides?
It's like it's like an equation just in brackets.
Yeah.
I think of it like that.
Yeah. You with me, Ricardo?
Just in adult order.
Yeah, he's still here.
Okay, still there. Okay, good. Now, I'm going to do something special with this. So now I end up with y by itself. That's good. Perfect. Now I just need to solve what this is. Because they say they want the answer in scientific notation. So I have to take this mass and change it so that I could get it into scientific notation. So notice that this have 10 to the 10, right? See that? And then this also have 10 to the 10. See that? Both of them have 10 to the 10. You see that? You see that, right?
We observe it.
So that means that we could factor out the 10 to the 10. Because what I did, I factored out the 10 to the 10 because essentially I could expand this out and get the top again. Because if I do 10 to the 10 times 6.5, that's this right here. And if I do 10 to the 10 times 1.2, that's this. So I could rewrite the top in a more compact way by simply writing 10 to the 10, open bracket, 6.5 plus 1.
True. True.
You see what I'm saying? We understand that step? That's a very important step to this question.
The factorization, right?
Just factorization. And then what I did after that was I added the 6.5 and the 1.2 to get what? 7.7. Right? We good?
Yeah,
Oh
basic
no, you
addition.
lose. You lose me.
Where I
On
lose you, Nancy.
you lose me the one before that.
Okay, so when I factorize the 10 to the 10 again.
I was lost.
Okay, so the idea here is, let me see. What I'm gonna do is let me take a screenshot. Let me crop this so I can actually write on it. So what I did essentially, right, was maybe if I use an example, you can see what I did. Maybe to show you what example. So if I say, right, and this is we know how to do this. If I say AB, no, that won't be right. Plus, yeah, that's it. AB plus AC. Can I factor this out? How can I factor this
A
out?
plus A.
Open bracket. B
A. I mean B.
plus what?
I confused. Why you put a bracket?
That's how we always do it. Because A times B is AB. And A plus C
Plus C is is
is
AC.
AC.
Okay, I get it.
That's how we always do it.
Oh, so that's why you put it on the outside. So when you multiply
Yeah, you
inward,
multiply it.
it expand.
Yeah, it'll
Oh, makes
expand.
sense. Okay, I
So
understand.
K times F plus K times Y. What would that be?
So be K on the outside, bracket F plus Y.
Plus Y. Because I can do K times F
To get KF,
and K times
I think
Y
Y to get KY.
to get KY. Good. So keep that in mind. That's factorization. So with that being said, let's bring this back. And so the idea here is that we're saying what
Let's see what this is.
should have come earlier, you'd have known.
Wow.
This is
Man.
PE.
So where did
But
I
I just
stop?
And they totally understand. They ain't lost a lot. They get it.
Yeah, they just want to see if we could use this factorization with algebra.
With numbers. So look, this is 10 to the 10 and 10 to the 10.
Yeah, and so
So
they
that's
like terms, so you
so
have to take them out.
Say it again. Say it again.
You mean me?
Yes, yes, sir.
Because the light terms, we have to take them out.
Yeah, because if they are like terms, we could pull it out. So 10 to the 10 and 10 to the 10. Remember, it's just like the A, B plus A, C. We have A on our two of them. So we can just say A open bracket, B plus C. And then just multiply that.
Factorizing.
Yeah, factorize. Just multiply that by that. So the same thing with this one. I can say 10 to the 10 times 6.5 to give me 6.5 times 10 to the 10. And I could say 10 to the 10 times 1.2 and give me 1.2 times 10 to the 10. So it's the same thing.
my question is, why did you drop the one?
Why did I drop the 1 1?
Yeah, at the bottom here.
Right here? How did
No,
I
when
do
you
that?
have no no when you have 7.7 over one point
No, we ain't
one.
reached down there yet, Nancy. We ain't there.
Oh,
We ain't
oh,
there. We
oh,
ain't there.
oh, sorry.
We ain't there yet. That's why I don't like giving the whole solution yet. Let's get let's focus on where I is.
Sorry, I thought you was down there.
No, I ain't
Sorry.
down there. Okay, good. So we understand why we have 10 to the 10, 6.5, 1.2, right? Good. So we add it now. 6.5 plus 1.2 is what?
That'll be 7.7.
Good. That's where we get the 7.7. And then this 10 to the 10 times 7.7. So we could flip it because multiplication is commutative. That means the way we multiply don't matter. So we just can say 7.7 times 10 to the 10, right? Because they saying the same thing. So 10 to the 10 times 7.7 is the same thing as 7.7 times 10 to the 10. We agree?
Yeah.
Yeah.
Same answer.
Same thing. So, and I did that because I wanted to be smart. I wanted to arrange my numbers by themselves and my 10, my powers of 10, or I say my indices together, okay? Or I just say base 10 numbers together, okay? That's why I arrange it like that. So now I can just divide. So 7.7 divided by 1.1. 7.7 divided by 1.1 equals what?
7.7.
7.
Just 7.
7 by itself.
For real?
Mm, it's okay.
Oh, so that's how you drop it.
That's how I got the 7.
Oh.
Yeah. And then 10,
Gee.
10 to the 10 divided by, so 10 to the 10 divided by 10 to the negative 16 is going to be equal to, remember the laws of indices? If you divide in with the same base, you could just subtract. So it's going to be 10 to the power of 10 minus negative 16. Okay, that's how the rule goes. So if you divide in with the same base, you can subtract the powers. Okay, we got that?
You always subtract the powers and divide them with the same
So,
base?
Yeah, we always do that because remember, if we have a to the n divided by, sorry, a to the m divided by a to the n, that's going to be a to the power of m minus n. That's the rule.
There, Mr. Petit.
Yes, Miss Cooper.
Oh, but then if we multiply this, then that's when we add.
Yeah, when you multiply, that's when you add. Yeah,
Oh, so this is where this concept comes in.
yeah, yes.
A over N and okay, makes sense.
Good. I'm glad you're getting it. All right, good. And then, so from that, now we go back to our word. So from that, it's going to be negative and negative, which gives us a positive. And so we get 10 plus 16, which is going to be what? 26. So y equals 7 times 10 to the power of 26. And is this in scientific notation?
Yes,
yes,
sir.
sir.
Yes, sir.
But all is really word for points?
Yeah.
Ain't 7?
They're trying to say that this should be the basics for you.
Oh, interesting.
And to be honest, I really elaborated certain things. I scratched certain things. Like certain things we could have done together. So like how I send this over and then kept this and then wrote it again. I could have do that right there. I
Oh,
didn't need this
you
second.
did it the long way.
I did it long to show you what I did. You know what I mean? You know what I mean? But certain steps could have been combined together in one. You know what I mean? But if I had to do that, that'd have been mucky. And so I just said one. I just wanted to scratch it off. Like from here, I could have factorized. You know what I mean? I could have factorized. I could have factorized and canceled at the same time.
Can you go to the very top, please?
Very good. So, so y equals to 7 times 10 to the power of 26. Okay. I can move now, Nancy.
Yes, sir.
Okay, good. So after that, a quick motivational corner. Who wanna read this one?
I'll read it.
Okay, go ahead, one.
Don't wish it was easier. Wish you were better. Don't wish for less problems. Wish for more skills. Don't wish for less challenge. Wish for more wisdom. Jim Rohn.
Jim Brown. Yes, sir. That's the motivational quote for tonight. Okay, let's move on. Hmm, this question, number 5.
Can I step out for a minute, please?
60 seconds, no problem. Okay, so you know what that means, right? Floyd? Floyd also gone. Floyd Tapo too. Ah, bye. Okay, let's go. Okay, so calculate the area. Okay, so calculate the area of triangle ABC. How would we do this? Any ideas? It's just 2 points. How would we do?
AB sine CO2.
Over 2? Okay. No, no, there's no over 2. You're mixing up the two formulas together. Oh, wait. Yes, you're right. You're right. There's over 2. It's half. Yes, half AB sine of C. You're right. You're right. So, what is A, what is B, and then what is sine C? So, the idea here is that,
Is 15
so it's going to be 15 times A.
times 20.
Mm-hmm.
And C sine C is 30
Yeah, sine C is
over
30.
2.
Very good. Over 2. Very good. But I just have half of it. Okay, you could do over 2 or you just do half of it. It's the same thing. All right, so, okay. So I just calculated 15 times 20 and divided that by 2. And that gave me 150, notice I said centimeters squared. Okay, I don't know why I put this in red. It's supposed to be in blue. Good. Now sine of 30, if you do it in your calculator, that's going to be 0.5. Okay, and then the area of the triangle ABC is going to be 150 times 0.5, which is what? Um, 75 centimeters squared. Okay, so that's how we did that. Any questions on that?
We still on question A?
C.
Okay.
Any questions on that? Any questions on question A? Hello?
Is the
Hello?
thing the triangle that says ABC is enlarged? That's the answer.
No, 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 no. It says this is just for A. So calculate the area of ABC. Okay, so we just
That's just A.
yeah, we just doing for A. So A is calculate the area of this triangle ABC. So we ain't reached the B yet with the enlarged thing. You understand, Nancy?
Yes, sir.
Okay.
Is that a part of B?
Yeah, the enlarged part is part of B.
Why is in 30?
Okay, that's just the formula. Because remember, the formula says, if you go to your formula sheet, the formula says that given any triangle, given any triangle, the area of the triangle is going to be what? Half of AB sine of C.
And wait, this isn't the same as the top. We have a half AB
Half
sin.
base times height divided by 2?
Yeah.
No, No, this is
So
the
how you tell the difference?
because or how you
Mr.
tell
Batik,
how you, yes sir.
we only use this formula when we don't have a height, right?
Yeah, when we are not given a height.
Yeah.
So
Okay, you gotta show me what you mean.
okay, so for example, right? Remember the height is always perpendicular to the base. So where's the height in this question? Remember the height is always perpendicular to the base. So if they'd given us the height, they would tell us say the height. They would tell us what this is, right? They would tell us what this is, right? The height is always perpendicular to the base. We don't know the height, okay? So this is the base 20, but the height have to be perpendicular to it, right? That means it forms a right angle with it. But they don't tell us what the height is. They just give us the sides. And so we can't use base times side over 2 because we don't know the height. So we have to use this one. Now, if per se, we had something like, the regular boys, the regular ones that go like, you know, that go like this. If it's a right angle triangle, we could easily use base times side over 2 because this side will always be the height. So let's say this is 7, and let's say this is 8. This is going to be the height. This is going to be the base because we know this is the height because this is perpendicular to the base. That's when it's a right angle triangle. If it's not a right angle triangle, then we have to use half AB sine C. But sometimes even if it's not a right angle triangle, they would tell us, they would say, hey, yeah, it's not a right angle triangle, but guess what? This one, this height is say, I don't know, 4 or something like that. And then the base is like, 5 or something. And so they tell you, okay, but see, it's still perpendicular to the base. And so that's the thing. Is that clear, Nancy? On when we use what?
Mm, okay, I think. Gotta probably put it into practice, but I understand.
Yeah, like we haven't they didn't tell us what the base is in this question, eh? They just let's go back. They just tell us, hey, this is 15, this is 20. There's no way of telling. Um, so that's the key. Notice that for C, you have to choose 30 wisely because your angle when you're using half ABC, the angle that you choose for your C must not be an angle that's associated with any of these other sides. And what I mean by that is that notice sine 30, right? This side that is corresponding to it or that is opposite to it, we don't know the length. So that's why um, we could use sine 30. If we was using, if we didn't know, say for example, let's say this was 75, right? Or let's say that this was 25. We couldn't use these angles for C. And the reason for that is because we already using the 15, already using the 20. That's associated with this angle and this angle. Right? And so be careful with what angle you use for C. It have to be an angle that is not associated with these two sides. Okay? So here, 30 degrees, it's on its own. It's not associated with the 15, neither the 20. This 30 degrees is connected with AC, and we don't have no length for AC. All right, and so that's why we could use 30. Okay, does that make sense?
I get it. I see what you're saying.
All right, I guess the ones who, if you don't understand, please don't remain silent. Let me know. I don't have no problem repeating this myself or explain it again.
So the angle have to be on the same side of the numbers.
The angle, what I'm saying is the angle does not, it shouldn't, okay, let me show you. Like, for example, let's say, right?
I understand what you're saying,
Uh-huh.
but I'm talking about visually. Visually,
Must it be in the corner of them?
no, it like have to be on the same side with them.
I don't see why that's necessary. You don't have to. Like, for example, it could be something like this. So let's say this is 15 centimeters, and let's say this is 20, right? Okay, this is your A, this is your B, right? Now, this one, this side is associated with this angle. You can't use that angle for C. This side is associated with this angle. You can't use this angle for C. You only could use this one for C. Let's say this is 30. Let's say 35. So this is going to be your C right there.
But you see that the angle is between the two
Oh, you mean that's what you mean?
known
Basically,
sides. That's what I mean. Like the
oh,
angle between the two known sides.
I mean that's an interesting observation. I mean, I remember it though. I just remember it concerning like that. Maybe that works all the time. I'm not sure. Maybe it seems right. Seems right. Seems like a general conclusion. Okay, like sandwich in between it.
That's why it's often.
Yeah, I figured you going for food, boy.
I ain't even eat breakfast.
And you have a class for 6 hours, and you only eat breakfast.
I forget. I was going to sleep if you didn't call me.
They sleep. How do you sleep on a whole day? But I can't do that, No, boy. I'll kill myself if I sleep one day. What? Sleep in the night.
It's possible.
Sleep in the night. And even in the night, you already know what happens in the night.
I sleep in the night too.
In the night, what the man say is what? You're toiling.
Mm,
Right. Okay then.
under my sheets.
And then they ask, Mr. Petit, how you get so good at maths? Okay. Keep wondering.
No breaks off him, Mr. Petit.
Telling you all the secrets.
Hey, while he was under his sheets on YouTube, I was at my desk doing algebra.
Exactly. I just made these stuff. Just made them. All right. Okay, so here we say, oh my goodness. I'm so glad I did this again with y'all because this answer is wrong. Look at this, right? We said that we enlarge the scale factor by 3. And so what a scale factor does, I don't know if you know what a scale factor does, right? But what it does is that, let's say, for example, we have an angle, not angle, but a triangle or shape, any shape. Let's say that this is 3, this is 5, and this is 4. Let's just say. And then we increase it by a scale factor of, say, let's just say it's 3. Okay? Then the bigger triangle that we get is going to be what? What's going to be this side?
So you take like the cube of each one.
Not cube. Not cube. Not cube.
So you
Factor.
square it.
Not square. It's a
Oh,
factor.
okay.
So if it's a factor, that means you're going to multiply it. So 3 times 3 is 9. What's going to be the length of this side?
25.
Mm-mm.
15.
15, very good. What's going to be the length of this side?
12.
12. Okay, so I just multiply each
You
side.
literally just multiplying them by 3.
Yes, just multiply each side by 3. And so therefore 3 is what we call the scale factor. Okay, good. With that in mind, if we go here and we have this guy, we take this triangle ABC and we enlarge it, okay, by a scale factor of 3. So what would be the new length of this side if we enlarge it by a scale factor of 3? So instead of 2, I'm going to have to use 3 and 3. So what is 3 times 15?
45.
3 times 15 is 45. So I was wrong here. And then 3 times 20 is what? 60. And so that's going to be 45 multiplied by 60, which is 2,700. No, 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 no. Divide that by 2. So 1, 3, 5. And divided by 2 again. You get 675. Okay, so let me explain what happened. What I did was I said, okay, if we have 15 and 20, when we multiply it, we get a new triangle. So let me show what I mean. Like, because we using a scale factor of 3, right? And so, right? That's the question. Hello?
Why did you choose to use 3 instead of any other
That's
number?
all.
Okay, because
Oh,
they said in the question, ABC is enlarged by scale factor 3.
oh, okay. So I didn't see that.
Yeah, so that's it. So that means that when we enlarge it, we get a bigger triangle, right? But one thing with enlargement, the angle never changes. So this is still gonna be 30 degrees. Angles are not affected in enlargement. Okay, so times 3. So what is 15 times 3? I think you said that. That's what.
45,
45. And then 20 times 3 is
60.
60. So now they want the area of this new triangle. How I'm gonna get that? I'm gonna what? Use the same formula, right? Half what? 30 times what? 60 times what? Sine of um 30 degrees.
Isn't the 30
Wait,
supposed to be a
you mean 30
45?
or 45?
45. Thank you. I don't know why I put 30. Thank you. 45. Okay. And that's what I did in my answer sheet. I said, you know what? Let's simply um but I just do it inside one time. So I just say a half of 3 times 15 times 3 times 20. So I can be 45 and 60. And then I do 45 times 60 divided by 2. Sine of 30 is still 0.5. And then that's how I got this, the 675. Are we good? Any questions, comments, concerns? Hello?
Hello?
Hello, yeah. I'm asking you. Any questions, comments, concerns?
Not right now.
Okay.
Are you just do the same thing that's on by a scale of 3, right?
That's all I did, yeah. Okay, good. Please, when I ask you,
Mr. P,
go ahead.
why the questions look so difficult, but when we do it, it'll be easy?
Yeah, they look difficult, right? But that's all they try to scare you. But it ain't undo it. Ain't undo it. Good. All right. So here I did not put any motivational quote. Um, I just didn't want it to feel like a motivational quote book. This was getting redundant, so I'm like, let me just leave it for now.
So is that a way of saying that? Yeah, motivational quote book limited.
No,
So you
I have no,
can't use it sparingly.
I have no, I have a lot. It's just that I just didn't want this to make this is an answer key. I mean, like, I didn't want it to feel like a motivational quote book. You know what I mean? And so
So you don't want saturated with it.
yeah, then it loses its, you know.
I mean, it would encourage the students to turn, like, after they finish, learning the equations and stuff, then you get an encouragement message afterwards, and you'll feel good,
Oh,
after you complete a page.
that's true. You would. I just this was getting a lot, and then I like the style. I didn't like the style of the thing, so I don't even want to mess this up anyway. So anyway, but I guess I'll put something. All right.
I mean, you don't. It don't have to be like a long quote. Like it just
Mm,
could be like a statement, like
mm-hmm.
"keep soaring," something like that.
Yeah. I can't, but I must. Something like that. All right. This one is an interesting one. This one, I don't think we've ever done a question like this before in this class, and I'm glad that we have the day to do it, so I can show you all, because this was on the syllabus and we didn't get to do it. All right, so I'm happy that we are able to do it now. Is Nancy here? Nancy Poloweski,
Mm-hmm.
you're here? You're kind of quiet.
And then she has a cue.
I was multitasking, sorry.
Mm, okay. This one is you need this one because we haven't seen this one before, so I think all eyes on it.
What's the big?
Yes, sir.
Ain't that land times width times height?
Yeah, okay, so close, right? So remember here they say they want the minimum possible value. So that this is what is different. They don't just want you to give them the volume. They want the minimum possible volume of this cuboid. Okay, so that's the difference there. Okay. So here we're looking at minimum possible value. Sorry, minimum possible volume. So and they say each measurement is given correct to the nearest centimeters. All right. So when it comes to stuff like this, the first thing that you need to find for any question, minimum or maximum possible volume, is you first have to find what we call the greatest possible error. Okay, so that's what you have to first find first. Okay, once you find the greatest possible error, then if they ask you for the minimum possible volume, you would subtract the greatest possible error by each of these volumes, and then you'll get the minimum possible volume. If they ask you for the maximum possible volume, you would add the greatest possible error to each of these volumes. I mean, sorry, each of these lengths or dimensions. Okay. So how do we find the greatest possible error? Okay. Now, if it's a whole number, right? So if it's like to the nearest centimeters or the nearest meters or the nearest you know kilometers. So these are whole numbers that they give you. If they give you whole numbers, then the greatest possible error is always 0.5. Okay, so that's standard. Okay, so if they give you whole numbers like this, the greatest possible error is always 0.5. So what you're going to do is you're going to subtract 0.5 from each of these. So that's what we did. So the minimum possible error, we call it L. The minimum possible error for the length, we first find the lowest possible length, so it's L min times the lowest possible width, L min. Sorry, W min times the lowest possible height, H min. So it's going to be 5 minus 0.5 times 3 centimeters minus 0.5 times 7 centimeters minus 0.5. And then you're going to multiply them out. Well, find their value, each of them, and then multiply them out um, to get your volume. Now, volume is always in centimeter cube. So I need to put that in centimeter cube. There we go. Good. So that's how we find the minimum possible volume. Any questions on that?
Mr. D,
I confused.
0.5. Where that come from?
Thank you.
That,
I
and that's the greatest possible error.
That's the greatest possible error. That's a rule. Should I write the rule down?
Yeah, Mr.
it
D, yeah.
Hey,
ain't
that's
even
supposed to
the
ask for
Please
that.
tell me everything.
ain't
Oh,
ain't even the rule. I just lost.
You lost? How you lost?
Mr. T,
Okay.
from you start talking numbers, I was then gone.
So, Mr. D,
Uh,
if the minimum is 0.5, the maximum is 1/8.
no. So the greatest possible error. Okay, so for whole numbers. Okay, I have it here. Why am I doing all this work? I have it here. It's there we go. Good. This should be right now. So this is helpful. Okay, good. Good. There we go. So this is the reasoning behind it, right? So so you want to find the minimum and maximum volume, taking measurement error into account. So like we said, find the greatest possible error. Each measurement was made to what? The nearest whole centimeter. So the greatest possible error is half of 1 meter, which is 0.75. Sorry, 0.5. That is the rule, right? That's just the rule. So if they give you something to correct a whole number, right, whether it be centimeters, meters, kilometers, it's gonna be 0.5 of it's always gonna be 0.5 of the unit. Okay, so if it's meters, 0.5 meters. If it's centimeters, it's 0.5 centimeters. That's how we get the 0.5 centimeters. Because each of the numbers that they give us was a whole number. So in our case, well, we have we have 7, we have 5, and we have 3. Okay. So for this one, it's just gonna be 0.5 because each of them is given corrector a whole number. Now, if they give you corrector, like the first decimal point, so like this was like 7.1, 5.2, 3.4, then it's going to be something different. But if it's whole numbers that they give you, your greatest possible error will always be 0.5. Excuse me. Now, what you do with your greatest possible error, if it's a minimum possible volume that they're asking you, you would subtract your greatest possible error to each of them. If it's a maximum possible volume, then you would add your greatest possible error to each of them. You understand?
Yes, sir.
Anyone else? Speak now, or forever hold your peace.
Um,
Are you following?
Mr. Boutique, I I don't. Is there any other way you could explain it?
Okay,
But I have to step off 1 minute because an emergency. So I want to explain it, but I don't know. Okay, I'll just have to copy it. Don't worry about that.
okay. All right, so, I guess we can explain it some other time. See, because she right now, she can't get it. But,
So, so like you said, a whole number, the greatest possible error would be 0.5.
yeah,
So, if
always.
a whole number, what would the greatest possible error be again?
You say if it's not a whole number?
Yeah, I think he was explaining that.
No, I never explained what happens if it's not a whole
Oh,
number. I never explained. Only for whole numbers I explain. So,
okay.
for whole numbers, the greatest possible error will always be 0.5. All right, and then what you do is you always subtract that from the units that they give you. Okay.
So this is like length times width times height, but more to it.
Yeah, this is the same thing, length times width times height, the same volume thing. But notice I use L min and W min and H min because I'm trying to get you all to understand that this is the lowest length I could use.
Okay.
This is lowest width I could use. This is the highest. Sorry, this is the lowest height I could use. Okay.
Okay.
And so that would be so that would be 4.5, 2.5, and 6.5. Now, if we want the maximum possible volume, we had to add the 0.5 to each one of them. So then it'll be 5.5, 3.5, and then 7.5. But here they didn't ask us for the maximum for A. They asked us for the minimum. Okay. Now, for the maximum, okay, for the maximum possible volume, or in this case, they asked you for the maximum possible total surface area of the cuboid. All right. What you first have to do is you have to notice that here I use L marks, right? So L marks. So first of all, you have to know the formula for total surface area. The formula for total surface area is 2 times the length. Sorry, 2 open bracket length times width plus width times height plus length times width. That's the formula for total surface area. That's the formula you just have to know. Okay. Total surface area of a cuboid. I wonder if they have that in the formula sheet. Let's see. If they have that in the formula sheet. Total surface area. I hope they do. If they don't, that's interesting. What are we looking for of a what? A cube? I don't know.
Yeah, cube.
So they memorize that. No, not man. They didn't give us total surface area. No, so you just have to memorize that. So for any cuboid, the total surface area is going to be twice length times width plus width times height plus length times height. But we add in something extra. We're not just looking for the length. We want the highest length possible. And so we get that by what? L max is going to be 5.5. Why is L max 5.5? Someone tell me. Why is it 5.5?
Because we have to add 5.
We had to add 0.5 to it. Okay, so this length was 5 centimeters, but I add 0.5 to it because I have to add my greatest possible error. Then it's going to be times 3.5 plus the width times the height, which is 3.5 rather, times 7.5, which is the height, but the greatest possible height, plus length. The maximum length is 5.5. The highest height is 7.5. So all I did was I multiplied them out. Watch what I did. I multiply each of them first. Okay, so that one give me 19.25, 26.25, 41.25, and then I add them. Okay, to get 86.75, and then I multiply it by 2 at the end. Okay, so that's how we do minimum and maximum. Find your greatest possible error and either subtract or add it.
So, what's the logic behind this total surface area, though?
The total surface area. So total surface area, remember we talked about it before, right? When you deal with a cuboid, you are dealing with, so let's take for example this side, right? So you're trying to find the area of all the sides and then add them all together. Right? And now it makes sense because look, this is one. Let's start with this surface. So this is gonna be what? The height times the what? The height times the
The width?
The width.
the length, because 5 is the
Right.
length. So it's gonna be the height times the length. But this surface is not the only one that's like that. The one to the back is also like that. Okay, so it's twice we have to do that. So we have to do 7.5 times 5 to get the area of this rectangle. Remember, it's two rectangles that has the same dimension. You understand that? So the front one and the back one. The same thing for this one. We're gonna use the height times the width. But it's two surfaces that are just like this, right? So that's this one and this one. So that's where that come from. And then we also have this one here, right? And this one at the bottom, okay? So that's where the formula for the total surface area comes from. Length times width but twice of it. Width times height, but twice of it. And then length times height again, which is where when we have twice of it. Okay, so that's where that comes from.
I don't understand. So you basically, are you multiplying it by 2?
Yeah, we multiply in the end. We multiply everything by 2.
What in the world?
Nancy. Okay, the logic is clear. Okay, look.
Not trying to understand the formula itself.
That's what I'm saying. I mean, you don't know now. Don't try to understand the formula. Like we are days before the exam. Just learn the formula. Like you ain't like just learn the formula. Know the formula. But if you want me to help you understand why is the case, I could. But like just
I ain't even know. I just want to know how to apply. Okay, I'm still at the L max W max situation.
where were you?
I did have an emergency and I stepped out for a minute.
Let's see. Okay,
A
so
killing emergency, so had to quick
oh, so
run.
that's where the police came running. I heard that. I heard that the siren. Um. Okay, so watch this. This is the height. You agree? This is the height. Okay. This is the length. You agree?
True.
Me?
Yes, you.
Yeah, I think so.
You think so? Let me see. Come on now. This is the height. This is the length. That's the
Yeah, yeah, yeah.
that's length times height, right? So in order to get the area of this green one, we have to use what? Length times height. Would you agree? That's the area of the
Lane.
green one, right?
To get the entire front?
The entire front. The same
Oh, yeah, 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 yeah.
good. Now, but we have to do that twice because this also have the same area, height times length. Because
Mm-hmm.
you understand that?
I understand.
Okay, good. So that's gonna be 2 times LH. Good, perfect. Now let's use the different terms. So let's use ABB. And then this one is gonna be this one. So it's also gonna be the height, right? Which is still H. But it's gonna be multiplied by what? What is 3 centimeters? That's the what?
That's the width.
That's the width. So it's
No,
gonna be um width times height, right? But it's two sides that follows the same logic, right? So we have to account for both sides. Okay. So both these sides follow that same thing. So it's gonna be 2 times width times height. Good. We're almost done. We have to deal with the ones at the top. So we're gonna use say a purple for that. So the ones on the top would be this and this, which is really and truly the length times the width. So it's going to be the length times the width. And whatever applies to the top also applies to the bottom. It's going to be the length times the width. So these rectangles at the bottom also follow. So the
So
bottom,
that'll be times 2 as well?
yeah, it'll be times 2. So it's going to be plus,
Not 4, right? So
no, it's going to be 2 times
the
LW.
oh, okay, okay, okay.
So really the total surface area is going to be 2 LW plus 2 WH plus 2LH. Remember, we could factor out the 2. So it's just going to be 2. But since 2 is here, 2 is here, and 2 is here, we could factor out the 2, leaving us with 2 open bracket LW plus WH plus L.
I understand now.
Good. That's where the formula comes from. But we don't want a regular length. We're trying to get the maximum surface area possible. So we have to account for the greatest possible error that we could possibly have. You know what I mean?
Mm-hmm.
The greatest possible error that we could possibly have, like even if you use the most foolish measurement taker, the most foolishness be taken out of you is is a is an inaccuracy that is within 0.5. So like you could be the worst measurement taker in the world, but For us, you can't be no more than 0.5 off. Okay? So the greatest possible error that we could accept, right? Or the greatest possible area that we could accept for this thing is going to be L max, right? That's going to be the length plus 0.5. W max, which is the width plus 0.5. And it's going to be W max plus, sorry, plus W max times H max plus, of course, L max and H max, and then we close the bracket. So that's where this formula comes from. Okay? Now, applying the formula, we take the length, which we know is 5, but we add 0.5 to it to get L max. We take the width, which is 3, we add 0.5 to it to get 3.5. And we multiply that together. Then we take the width, which is 3, with W max is going to be 3.5, because we add 0.5 to 3. H max is going to be 7.5, because we add 0.5 to the height. And L max is going to be 5.5, because we add 0.5 to 5, and then H max is going to be 7.5, because we add 0.5 to 7. Multiplying each one of these, we get this one is going to be 19.25, this one is going to be 26.25, and this one is going to be 41.25. Then we add everything together, get 86.75. Then in the end, we multiply it by 2. And so that's how we get it. Any questions, comments, concerns? Yes or no? Let me know.
Not particularly.
So, Mr. Petit,
Yes, sir.
anytime we doing a maximum value, we add 0.5 to the number, to the length.
You add 0.5 or you take away 0.5. If it's maximum, you add always. Okay? If it's
Okay.
minimum, you subtract it.
Quick question. So, what's with why the top have minus 0.75, but down here you have why one is 3.5 and the other ones are 7.5.
Okay, good question. So remember, for the minimum possible volume, it's minimum, okay, not maximum. So we want the lowest that we could get. So we would not add 0.5. We would subtract 0.5 from each of these values. So here, remember, for the length we add 5, but since they want the minimum, we're gonna subtract 0.5. Same thing for the width. Um, it was 3 centimeters, but they want the minimum, so we have to subtract 0.5. Same thing for the height. The height was 7, but since it's minimum, we want to minus 0.5. Okay, then we get
All
this.
of them are the same. So why isn't the max the same? That's my question.
Okay, why isn't the marks the same?
Because all of them are minus from 0.5. So why when it's the max? Two of them minus from the same and the other one is minus from 3.5.
So and for the marks, everything is minus 0.5, right? You understand? For the min, everything is
Yeah.
minus 0.5. You understand that?
Yes, sir.
But for the marks, we add 0.5 to each. Look at this. 5 plus 0.5, that's how we get to 5 centimeters, 5.5 centimeters. 3 plus 0.5, that's how we get to 3.5 centimeters. And then 7 plus 0.5, that's how we got to 7.5 centimeters. I just didn't want to put it here because it would have been too long. So I just put it here at the bottom and then just use the values here. You understand that, Nancy?
Yes,
Yes,
sir.
sir. I gotta write that down.
You understand that, Nancy? You understand that?
Yes, sir. I just gotta write it down.
Okay.
Let me write it down quickly so that I make note of that. W max. I hope nothing like this come on. This is so difficult.
What difficult? You minus in 0.5 and added 0.5. And then multiply with the
I
thing.
think the difficult part is trying to remember the LW, the
No.
WH, the LH.
But that
Mr. Petit, why do you think the class quiet?
the class is
Mr.
quiet.
Petit,
No, I
Petit,
quite understand it.
the class is quiet.
One, you understand?
Yeah.
Yeah, that's what I'm saying.
Mr. Petit, can it come in different shapes?
It could come in different shapes. Yeah.
So
So
if
it's
it
only
come in,
me who lost? Wow.
Say it
so if,
again.
so if it come in different shapes, it can be the same thing.
Just use the formula. Use the formula, the regular formula of the thing, but subtract 0.5 or add 0.5.
So that stays the same.
Yeah, that stays the same.
All right.
So what about if it came in a triangle?
Okay,
The
so
same
for
thing?
yeah, just either subtract 0.5 for the minimum or add 0.5 for the
I
maximum.
mean for like the maximum possible value of this total surface area.
No, no, no. They can't ask you for surface area for a 2D shape. Okay, they could ask you for area of a 2D shape, but not total surface area.
Okay. So if it's a prism then.
Yeah, if it's a prism, yeah. But see, they could ask you for area of a 2D shape. In that case, you you would you would add you'd use the regular area formula, but then you would add the 0.75. Let me just show you all. I mean, let's just do several examples since it's a itchy topic. So minimum.
I like when you type minimum the first the next thing you come up is weight.
Minimum maximum volume. Okay, okay, this is good, huh?
So you know that's a popular search.
That's right. Listen, people want to know. People want to know. Okay, this one is for um. Okay, let's see. I want to sign in now. This one is for Nancy. The minimum is for Nancy. The maximum is for who won the maximum? Who won the maximum? I get okay. Alicia. Miss Rackley, give me the maximum,
Those.
and uh, Nancy, give me the minimum.
Do we have to? We just minus it from 0.5, right?
Yes, ma'am.
Oh, but it's 15.5. That's the minimum.
Pardon?
15.5?
Is the minimum?
I think so.
No. So you have
What?
the minus. Can someone help her? Someone help her.
Is it
Okay, can
156.75?
I
No.
can I get
What
my
I did?
answer?
What?
Can I get
Well,
my answer?
Wait. Let's stick with the minimum first, Miss Rackley. Then we come to you.
Okay.
well, we
Mr. Petit, the
subtract
answer
10.
7.
Say it again.
7.
No.
What did I do wrong?
Okay. You only found the minimum. You only found the L min. What about the W min?
Huh?
So you only found the W min. You only found the L min. So you minus 16 minus um 0.5, which gives you 15.5. But you also need to tell me what is for 17.
Oh, 17, 16.5 as well.
Good. So now what you gonna do with them two dimensions?
Multiply them?
Yeah, because this is what? Length times width, eh?
Yeah.
Good. So do that.
That's 10, but that's 15.
It's
I get 255 and 7.75.
good. 255.75. And what she did,
Oh, so that's what I.
yeah.
Okay.
So she took the 16 minus it by 5, 0.5. Took the 17 minus
I
it
thought
by
I was
5.
10, Mr. T.
That looked like 10. Oh, wow. So that's clear. All right. And then she took the 17 and then minus it by 0.5. Then she multiplied those two. So it's going to be 15.5 multiplied by um 16.5.
16.5.
Good. Now for the maximum possible area, what you got, Miss Rackley?
I got 288.75.
No, ma'am.
What did I do wrong?
Oh, no, 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 no,
Okay.
no, 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 no. Don't check that. Don't check. You might. Yes, you're right. You're right. You're right. You're right. You're right. You're right. You are right. She added 16.5 to give us six. She added 16 plus 0.5 to give us 16.5, and then 17 plus 0.5 to give us 17.5, and she multiplied them to give us 280.5, and then submit. Sorry, we get these right. Well done. Good. We don't need to do this, right? We don't need to do this, right?
Was it right?
That was right. They just said he said well done. They didn't get an
Why
answer.
they get 75 at the end of?
Say it again.
No, I'm just curious why they get 75 at the end.
Maybe that's just how the numbers work out. That's just how the numbers work out.
In the case like this, where I'd have three numbers, right?
Uh-huh.
We would do like, so we minus 0.5 from all three of the numbers, then multiply them,
Yes, ma'am.
and then place it in the space provided.
Yes, ma'am. So for the minimum,
Oh, okay. Now I understand. Some of this, why can't you didn't put in layman terms like that? I would have get it from the gun.
oh my goodness, I've been saying that. I've been repeating that, repeating it.
You said
Okay.
so fancy.
Oh my goodness, I guess that's the problem. Okay, so Juan, give me the maximum. Ricardo, give me the minimum.
I do the minimum is petite.
Okay, give me the minimum then. Ricardo, give me the maximum.
3,3075.625.
We said 3,000. If we get this wrong, who I can blame?
Almost Bidi.
You me?
Okay, we say 3,001.
775.
Uh-huh.
No, 3075
75, uh-huh.
point 0.625.
625. Anyone want a second his answer? No seconding of his answer. Give me the maximum, Ricardo. Let's go, Ricardo. Let's go, man. You gotta be positive, nah?
Hey, right now, hold on.
You ain't writing it down, man. Let's put it in the calculator.
I second one answer.
Yeah, I second the top one. Good. Let's go. Let's go, Ricardo. Put that in the calculator, man.
I have it. I can see if I can second it.
For him.
No, I know. I just say I wonder if I could second it.
I got 3,787.875.
I second him.
I second that too. Alright, so let's see if we are correct. Drum roll, please. You're so dry, wait. Goodness, drum roll. No one is drum roll. Wow.
Done, 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 done.
Good, good, good.
Yay!
Okay, good. All right, so we understand.
Well, you guys checking it.
Say it again.
So right?
Yeah, we ready. Oh wow. They just call us brilliant.
You really think we
How
would
did I
second it
always
if it wasn't wrong? If it was wrong?
Nah, Nancy. Plenty things you second be wrong.
I disagree with you.
All right.
If it's wrong, that means me and that person just as bad.
Yeah. All right. So let's go. Okay. So I think we understand that. So pretty easy stuff. All right. Dependent maxima. Just gotta know what you're doing. Okay. So I wish I should add a motivational quote in the interim. That'd have been nice.
I think that's pretty good.
Good. Marissa works a regular 40 hours per week with overtime paid at time and a half. Last week she worked a total of 48 hours in total. Wow, the sun's still out at 7:18. It's crazy. Marissa works a regular 40 hours per week with overtime paid at time and a half. Last week she worked 48 hours in total, letting X represent her hourly wage. Write down and simplify an expression for her total earnings for last week. Okay, very important question. I like this question. Read it carefully. I give you 60 seconds to answer. You gotta be thinking for this though. Okay, so 60 seconds on the clock. It has begun. I come right back. 60 seconds. All right, that's time. We got it? Anyone?
Um, X times 40 equals. No, I have 40 times X equals 40X.
40 times x equals 40x.
Mm-hmm.
Okay.
That could be wrong. I minus the 8 though.
All right. Anyone else? You want to second that or you want to give your one?
Hold on, wait. I minus 8. Do I have to include that? I minus 8.
Which one we do? What you want me to do? Keep it like this or it's your equation?
No, separated.
Which one?
40 minus 8
40.
times
Which one we do? 40 minus
X
40 minus 8.
times. No, 48 minus 8 times X equals 40X.
Just say it again. 48. Say it again.
That could be wrong. 48
Uh-huh.
minus 8 times X.
X, right there.
E- uh-huh.
Mm-hmm.
Equals 40X.
Equals 40. Equals 40x. All right. Thank you, Nancy. I like that you always engaging and giving an answer. Anyone else?
Oh, let me see the question again.
Come on, this thing been on for 2 minutes now. Mr. Bethel, where were you?
Uh, I just took a little small break.
Really? My goodness.
All right, I get it.
You got it? Okay. What do you think it is?
Does the total earnings include her 8 extra hour pay?
Mr. Bethel, what you think? I mean, sorry, what you want me to write?
Mr. Peter,
Um,
you just ignore my question?
Um, your question is gonna be answered. It gives it away though.
as I mute.
Go ahead, Bethel.
I would say 40, 40x,
Uh-huh.
and then x times 0.5.
That's times 0.5. 0.5.
Yeah.
So just leave it like that.
Well, I guess you could add them.
Yeah, okay.
Must go back on the question, please?
Okay.
For a quick second.
No problem. All right.
My answer would be x plus 48 equals 650.
So he's saying x plus 48 equals 650.
Yeah.
Okay.
Also, mine also equals 650.
Equals 650. Okay.
But isn't they didn't include 650 inside the first equation, right?
Mm-hmm. I don't know.
Yeah,
Let me go
yeah, they
back to the
did.
question.
They did.
They did?
Our journal earnings last week was 650.
Did they said that for the first part? Let's we go back to the
Yeah.
question, please. Oh my dear Lord. No, Mr. Particular, to go back to my question. Let me fix that, please.
Want to fix it?
Yes, sir.
How you gonna fix it?
I wanna put
Uh-huh.
48x
Uh-huh.
equals
Equals. Mm-hmm.
650. That's me.
That's that answer. All right.
My final answer.
Okay. All right. So the
I will
question.
fix mine too. I will put 1 instead of 0.
Yeah. Put one instead of zero. Okay. Put one instead of zero. Oh boy, it's a lot of tweaking in the exam, which y'all gonna be doing. Y'all only have a few moments, you know. So it'll be 1.5, as you're saying.
I didn't say the end result
Yes,
though.
1.5.
Okay. All right. All right.
That's short, so yeah.
Say it again.
Now I hear like shorts going on in some background.
No, I shots. Man, you're so attentive to people background. My goodness. Mr. Bethel, come on. All right, so let's go. So so here's the expression. So we're gonna let x equals Mercer's hourly wage, and if that's the case, then that means the following expression is going to represent our total earnings. And so we're gonna for last week now. So we're gonna do is we're gonna take 40x because it's 40 hours that she's working, right, for the basic week, right? And we're gonna add that to our overtime pay. Okay. Now our overtime pay is going to be time and a half. So time and a half is going to be 1.5. 1.5 times what? 1.5 times her what? Her hourly wage. Okay. But remember, she worked a total of 48 hours. So that means that she worked 8 hours overtime. And so that means that it's going to be 8 times that 1 hour of overtime, which is the 1.5x. So that's why I have 8 times 1.5x. Now, 8 times 1.5x is 40x plus, sorry, 8 times 1.4x. Sorry, 8 times 1.5x is 12x because 8 times 1.5 is 12. And so when I added those two, I get 40x plus 12x, which is 52x. Now, it is very important to note that her total earnings for last week being 650 does not apply to A. Okay? It says B is when they said use your results in A to write down and solve an equation for our hourly wage. So for A, they just want you to write an expression, not an equation. An expression is not gonna be equal to it's just a regular expression. It's not gonna be equal to any whole number. So here the answer is just 52x that equal to nothing. Okay, so that's the thing. Okay, any questions on that?
But you
Any
have
of
it
us
equal
was
to
close?
52x. So.
Say
Any of us
again.
was close?
No, I saying you have it equal to 52x.
When I say it's not gonna be equal to anything, this is just me simplifying it. This is not me like equating it to some constant. You understand? I'm just simplifying it.
Oh, so that's just the total.
Yeah, this expression represents the total amount. Okay,
Um,
I didn't set it equal to anything. Right?
So her earnings that go with question B.
I'll go with question B.
I know people. I gotta stop listening to Floyd, man.
That's the thing.
Man,
I
I
got
thought
to
Ricardo
stop
say that.
listening to
I thought I was
Floyd.
right, Mr.
Ricardo said it. Ricardo
Miss-
said it. Then
You
Floyd
all
listened to
need to
Ricardo.
stop.
Then Nancy listened to Floyd.
I
No.
thought I would have come in place, huh?
I know I better than this. No, I'm a leading female. This is not fair. I lately
Mr. Petita, yeah,
I
someone trying to judge answers, say who get the best answer.
Uh,
I never said I asked who was close. That's what
um,
who's the
I.
closest?
Mr. Petit,
We all know who's the closest.
Who's the superior student?
I know who's the closest.
Who was the closest?
It's clear. I don't even have to say it. It was clear who's the closest. I don't even say it.
You
Mr.
going for a
Petit,
male? Really?
I never said. What's in your mind? I say nothing. Go ahead, one.
you could explain your answer again. I can hear you when you
Okay.
was explaining for some reason.
Oh, you can hear me. Okay. Remember, the 40x is her basic pay, right, for the 40 hours, because x is how much she get paid every hour. So if she work 40 hours, it's gonna be 40 times x. You understand that part one? The 40x.
Yeah.
Good. Now she gonna work some overtime. Okay. Now her overtime is gonna be paid at time and a half. So um that means that we're gonna take her hourly pay and multiply it by 1.5. So that's time and a half. So that's why I have 1.5 times x. That's her hourly pay for 1 hour of overtime. 1.5 times x. Okay, for 1 hour of overtime. But she worked 8 hours of overtime. And we know that because she worked a total of 48 hours. She only supposed to work 40, but she worked 48. So that means that she worked 8 hours overtime. So it's going to be 8 times 1.5x. Okay. Then once we have that, we could simplify it now. So the 8 times 1.5 is 12x, and then 40x plus 12x is 52x. So the answer is 52x. Okay.
Okay.
Yeah.
So they want to see that 52x.
They want to see it because they said simplify an expression. So they want us to simplify it completely. Okay.
So no one's close then.
You can't see Mr. Petit just.
y'all are the judges. You tell me.
No, Mr. Petit, I am no longer listening. Bethel, you're no longer my friend. I disown you. And Ricardo, we were in exile. Because how?
y'all, y'all,
How did they fool me? How did they deceive me to think that 650 was a part of the question and I know it wasn't? Wow,
no,
that's
you didn't know
embarrassing.
it wasn't, because if you know it wasn't,
Because I asked a general question, you refused to answer me, and then you let them answer me.
I say that. You say you know. You say you know. So. All right, let's go. B. Use your results in A to write down and solve an equation for hourly wage. Okay, so let's go. So it's gonna be we know this will be gonna be 52x equals to what?
How wage for that week?
Yes, our total earnings. So 650. So it's gonna be 52x equal to 650, and then B. solve for x. What's the answer when we solve for x?
Mm?
What's the answer when we solve for x?
I get 12.5.
Very good, 12.50. So our hourly wage is $12.50. And so I hope you all see the pattern.
Uh,
Go ahead.
that's but I know normal hourly wage, right?
That is a normal hourly wage, yes.
How could that be? Because
Mhm.
it ain't in stone that she always work 8 hours all the time.
No, but see, remember, and I like that you asked that because we set
Total.
we set it equal to a total, all right, for last week. Because this expression, the 52x, is is an expression representing total earnings for last week. Think about it.
Yeah, I get that.
Hmm.
But what I'm asking is, that's not like a usual turtle earnings, basically.
That's not a usual total earning, but from this unusual total earning, we can still calculate a hourly wage, her hourly rate.
Yeah, I understand that, but I was just saying, like, she can't say that's her hourly wage.
Yes,
Because that's
yes.
like an outlier situation.
No, she can say this an hourly wage because remember her hourly. We remember we say let x be equal to her hourly wage. That's what x is. So when we
But in,
find,
like, it's the sense, like, in trying to make it, remember we did interquartile range,
mm-hmm,
and we say, like, we don't want those with two, you know, those outliers.
mm-hmm.
So if we try to, like, find the range of our hourly wage, it wouldn't be this because this would be considered an outlier.
No, no. That principle doesn't apply here. Let me tell you why. Because we set this is a true statement. If this is not a true statement, then
No, no, I'm not arguing with this. Yeah, I know that's right,
uh,
but I just saying, like, on a over a time of, like, say, a year.
okay, over a year, her total earnings would change, but her hourly rate is never gonna change. It's constant. So you can't use the changing of her total earnings um and mix it up with the hourly wage. Sure, it's
No, but I'm saying, like, okay, this only holds true if and only if she always works 8 hours overtime every week.
you mean this rule this
This
situation.
wage, yes, this
No,
hourly
no,
wage.
no, 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 no. This hourly rate is constant. And the reason why we know this hourly wage is constant is because the hourly wage is not affected by the number of hours worked.
Okay.
No, that it's not, it's independent. So that means that this is constant. What's gonna change though is how much hours she work, which will affect how much she make, and then you could start talking about the outliers on the total earnings, not on the hourly wage. You can't do that.
Okay, okay.
You know? Okay, so this part I leave blank because I'm like, what can I put here? And the next question is so long, and so I can't put it right here. So I'm like, what can I put here? So still thinking about it. Anyway, let's go to the next question. Solve the following quadratic equation, giving your answers correct to one decimal place. And this is 5 points. So go ahead, have fun. 60 seconds on the clock, and the timer has begun. 60 seconds. Solve the quadratic equation for me using any method, because there's multiple ways to do this. Any method you want.
Mr. Petit, with this kind of question, can we get more time, please? Just because I'm writing kind of slow. No mercy, I did not one. No grace. Job.
No grace. All right. All right. Any answers yet? Are we still working?
I still working it out.
Still working. Okay. So you need grace. Only Mother's Day. Only mothers get grace on this day.
Miss Bitsy, how do you add 3W and W squared?
You do not add them.
So that you're not supposed to add those kind of
No,
stuff.
you can't add them. Now it was if it was 2W and 3W, then yeah, you could add them. But
Mm.
W squared and 3W, they unlike terms.
So you just have to. Do you like try separate them and get them by themselves?
No, no, no,
No.
no. No, you can't do that. The only way you could possibly, you can't even. You could, you could go
I
ahead.
could square root it and take away the square.
No, that wouldn't work. I don't know, because you'd have to
Okay,
divide
I
both
t-
sides.
okay I tap a note then. That's me.
Top it over. Oh yeah.
Yeah, I got I the only thing I was able to do is add 8 to both to carry the 8 over.
Mm-hmm.
And then I have W squared plus 3W equals 8. That's me.
I see. Anyone
I don't
else?
know how to get
Uh,
rid of the W.
Okay. Anyone else?
Mm. Yeah, that's also what I got.
Okay. Anyone else?
Mr. B,
Yes, sir.
will the final answer be 2?
No, certainly not.
Oh my.
No,
Will the final answer be in a whole number?
no, it won't. Where's Alicia? Directly, are you here? I was one.
What about the plus 3? Can we do something with the plus 3? The plus 3W.
What you want to do with it?
Like, can we solve for that?
You can't solve for that in isolation, Alicia.
Uh,
Is the W factorized in some way?
Okay, okay, I like that. I like that. That's a way that you could factorize it.
wait, you could factorize the W? Let me see. Because they have, but all of them have nothing in common though. Like only 3. It's because it's attached to the W.
You could factor it, but
It's just complicated. This isn't that
there's a very important weapon that y'all have under your bosom that always works for quadratic equations. This is a quadratic equation. What do we always use to solve for quadratic equations?
Use a quadratic formula.
The quadratic formula.
That's what I'm trying to do now, but I don't know. I'm stuck. That's what I was using.
That's the method. Any other method for this question is not wise. So that's the hint. Use the quadratic equation.
Can we see the formula?
The formula for quadratic equation is
Is it like B with
I
They give it to y'all in the answer sheet. No, but it's x equals to
mm-hmm.
plus or minus.
Oh gee.
No, sorry, not B. Plus or minus.
What? Hold on. You say X.
Let me put it on the
Okay.
screen for you so you can see it one time. Other than me saying it, I think this is it right now.
Oh dear Lord, bless my soul.
Have mercy. All right,
This is not it.
this is the quadratic formula.
This is the thing that I asked you to go over. I suck at this.
Oh, it doesn't matter.
This is flat on terrible.
I remember when this is terrible. I didn't understand it for the life of me.
Okay, hold on. I think I get it by looking at this formula. So automatically where I put B, I'm gonna put W squared, right?
No,
What?
no, ma'am.
See, I didn't know.
Is that plus sign like a new special kind of sign?
Over.
Yeah.
Okay, so what it actually is, right? Is that this formula is actually two formulas combined into one. But because we're so lazy, we don't want to write the plus one and the negative one. We just say, hey, plus or minus. So it's actually two separate formulas.
I would like to do it separately. I think it'll be easier.
No, no, no. You don't want to do it separately. That's just too much time. All right, so let's go through it. Okay,
What's my
so so here we will use the quadratic formula to find the zeros of the given quadratic equation. And all the zeros of the given quadratic equation means is the solutions of it. All right, I just wanted to write it like that. So we continue as follows. So w squared plus 3w minus 8 equals 0. So that means, therefore, a equals 1. Why a equals to 1? Because the coefficient of your, your w squared term or your x squared term is always a. So a is always the number in front of x squared. And since is we have imaginary 1 there because it's nothing is there, so a is gonna be 1. B is 3, that's always the number in front of w. And c is negative 8 because that's always the constant term. Okay, now since we have it like that, we can apply the quadratic formula. We know that b is 3. But remember, the formula says negative b. So you have to put negative 3 plus or minus the square root of b. But b is again 3 minus 4. 4 comes with the formula. You can't change that. A is 1. Okay. And negative 8, which is c. And so we have 2 times a. A is 1 again. We know that. And so all I did was I evaluated the stuff in the mid inside the or underneath the quadrat the square root. 3 squared is 9 minus 4 times 8. 4 times 8 is 32. But we have a negative and a negative. So a negative and negative end up being positive. So we have 32 plus a 9. That's where we get the 41 from. Okay, so we have the square root of 41. So we have that w is equal to negative 3 plus or minus the square root of 41 divided by 2. But now remember that this is plus or minus. Remember I told you it's two formulas combined into one. So at this point is where we split it. So we consider the positive side and then we consider the negative side. So for the positive one, we only write the positive. For the negative one, we only write the negative. That's what we mean by plus or minus. Okay, we splitting them. So w sub plus is going to be negative 3 plus the square root of 41 divided by 2. And the answer for that is going to be 1.7. But they want it to one decimal place. And then negative 3 minus the square root of 41 divided by 2 is negative 4.7. But again, they wanted the 1 decimal point. And this is how we would apply the quadratic formula to answer this. Okay.
When you have the 4 times 8, right?
Could you go back up quickly, please?
Mm-hmm. Go ahead.
You have the 4 times 8 and the 3 squared.
Yeah.
Where did you come to add them? Where's the plus sign?
Negative and a negative is a
It's a positive.
yes. So this end up being a positive. Because think about it, this will be negative 4 times negative 8, which is what?
That's a positive.
Positive what? 32, right?
Yeah, that's a positive. But and you take that negative from the 4 to make it positive.
Okay, so essentially what we have is, let me just write it out for you so you can see. Um, so we have 3 squared minus 4 times 1 times negative 8, right? Now, this is 9, right? We can write this as, we know that it's going to be negative 4, because 4 times 1 is still 4, right? Minus 8, right? Equals, it's going to be 9, negative times the negative is going to be positive 32. That's 9 plus 32, which is 41. You understand that?
Okay, okay. I didn't know you could like put the positive sign in.
Mm-hmm. Good, good. That's fine. That's good.
I thought you would have like had like after you eliminate the two negatives and you get a positive number. I thought you would have then um multiply them because it's just been to two numbers.
You would multiply them, certainly. Certainly you would
Could
multiply
you
them.
go scroll down for me, please?
Any questions, comments, or concerns? Y'all gotta speak to me now. It's only a few of y'all.
You could go down.
Mr. Badi,
Yes, sir.
can you do next one, please, like in a different way?
The next one in a different way. Okay, so you want the next one of these? No problem.
You scroll back up, please.
No problem.
So they always come in this kind of form, or other way,
They could
like
switch it up.
with the square face.
Okay, so they could switch it up. Okay, so they could switch it up. If they switch it up, it doesn't matter because A is always the number in front of the square term. B is always the number in front of the the single term, if you want to use that word, and then C is always the constant. Okay, so it doesn't matter how they switch it up. You have to follow that principle. Um, and so that's that. Um, let me give y'all something. So,
Hey, Mrs. B, I
I
was trying to get
almost
the
thought.
I was trying to get the answer to understand it, but you keep moving the screen.
okay, no problem. Sorry about that. Answer.
Thank you.
You say the B is always equal to the coefficient?
The coefficient in front of the variable that is to the power of 1, and the variable that's to the power of 2.
With this, I just need total practice because I ain't even attempt to understand.
You said there's another way to do this?
There is another way. Um, uh, factorize it. Um, you could factorize it. Um,
Thank you.
I wouldn't advise that way. Straight up, I wouldn't advise it. I wouldn't.
Why?
It's just because you notice how we did with square root, and so with
Okay.
factorizing, um, hmm, you would have to think. I mean, no one knows how to count in square root. I mean, who it's difficult. Really difficult to really put that together. So the answer is straightforward. So I wouldn't advise that for this question. Certainly not. The quadratic formula is the best way for this one. Yeah, it's the best way. You can't really override that. This is the most efficient way to do this question. Now, someone asked me to do another one, and so let me show you. There's a whole host of questions like these, and I have a book that just have a bunch of them. Um, this is gonna be one of my favorite texts. Um, One thing I love about the university, when you go there, they just fill you up with textbooks that you be like, whoa, gee, okay, let's go, And so,
Is university maths hard? Like extremely hard.
mm-mm. If you do not understand BGCSE, then they can hit you hard. Most persons who get a problem with them is because their BGCSE was failing. So stuff like sets, this by the way, this is the book they use in Maths 163, right? Um, this is the book that they use in this is also the book that they use in Maths 169. And look at the syllabus. We still have what? We still have sets, right? We still have probability, right? We still have matrix, right? We still have linear equations, right? We still have functions, right? Linear models, straight line. So why do people have problems with that? It's because they did not understand high school maths. And so by the time they put another layer to that, their foundations is weak, so of course it'll be hard to them. But what's hard is not the new stuff, because it's not much new. What's hard is the old stuff compounded. That's the problem. Um,
And these students they is carrying on so bad, like this like brain buster work, like,
no,
nothing I've never seen before.
so quadratic functions and then their models is a good exercise for you. Good stuff there. So
So why every page of a parabola?
that's quadratic functioning. Okay, so
Kids actually read that book
they don't. That's why they don't do well in the class. But I do.
because it's so much words that
Shh.
can you read it?
We didn't start on that yet. There's so much words. It's a good book. I love the book. If you really want to
Yeah,
understand it,
yeah. We know that you ain't normal. You excused.
anyway.
Miss Potato, you suck your teeth so much time
Hey,
for
Miss
this
Petite,
tonight. I
Miss
swear,
Petite,
all the
show that
attitudes.
quote again.
Should have caught it again. should have caught
What
it
up
again, eh? Should have
what up
caught
with
it.
your
Yeah,
attitudes,
you
man? What
gotta
I
show the
do?
quote again.
You that. You ain't doing that. That's a
You suck your teeth so hard that could have hurt.
That's a sarcastic suck teeth. That's not a.
That's the attitude. All kind of attitudes in that one.
My goodness, that's a sarcastic suck teeth. All right,
Yeah, that's
do
what
this
they
one.
say.
This one is nice. I like this.
What
So
is that?
okay, so use the quadratic formula. This one is nice.
So when you see fx, that's the automatically quadratic.
No. I can
Isn't
prove
that
that.
functions?
That's functions, yeah.
So why are we using the quadratic formula to do function?
You'll see. You'll see, my dear.
See, this is where they lost me again.
You'll see. All right. So I just
Miss
wanted.
Petite, you know that we ain't all the way that bright now.
Y'all are. Don't say that.
Well, I wouldn't say we. I would stick.
Okay, you want me
I
to
would
single
stick to
myself out?
singular
Okay.
language.
Single myself out? Okay, Mr.
Oh
Petite.
my goodness.
Everybody
I
nothing.
I take them where I retract my
Uh,
words.
she does not speak for all of us.
I take my words back. I'm so sorry, class. I did not mean to offend you guys. But see, I ain't got it together. So
uh, all right,
we'll
so
be
let's solve this. So equals to 0. Now I want you all to look at this, right? And what I mean is, look, there's different ways I could ask the same question. Before you answer this, I just want to show you different ways that I could ask the same exact question. I could have say 3x um, plus 2 equals to negative x squared. And that's the same question, you know. You all see what I did?
Yeah, we wrote it backwards.
More than I wrote it backwards, I send the x squared over,
you send it over and you minus it.
right? And so before you apply the quadratic formula, you have to make it look like this with the 0 here. If it's not like that, then it's not going to work. Okay? Another way I could ask the same question is I can say x squared equals to negative 3x minus 2. Okay? It's the same question. So don't get surprised if they kind of, switch it up. I could also say x squared equals to negative 3x plus 2. It's the same question. But before I do this, right, I must convert it to this. Right? And how would I do that? Send the 3x over and put the x squared in front of the 2 so that everything will look like this. Because I can't use the quadratic form if it's not looking like this. Is that clear?
You mean put the x squared in front of the 3?
Put the x squared in front of the 2. When I send over the 3x, make sure it's positive so that everything looks like this.
But
You
if
must
you putting the x squared in front of the 2, then where you putting the 3x?
In the middle, just like how it is.
Okay. So we something like PEMDAS, BIDMAS,
How you say that?
where you always have to do the thing on first, the indency, and then multiplication bracket, and then add and subtract.
No, it's not like that. It's just that it have to be in this form because the quadratic equation only respects it when it's of this form.
Yeah, but it like a similar rule though.
No, it's not the similar rule. I mean, if that's how you think about it, then I mean by all means, but that's not like that. Okay, so
You say we're using the
quadratic
that
formula
crazy equation to do this.
to do this, yes.
Yeah, don't mention that name. Yeah.
Quadratic formula. Quadratic formula. Quadratic formula. All right, so how much seconds we need? 60?
Can you pull up the? Hold on, let me get the question first.
And then you need the formula, right?
Yes.
So
In on the paper, you say? So I have the number I have.
it's
Oh,
F.
gee, that's definitely a no.
I remember trying to memorize it, but after you do so much questions, you will know.
That's what they say. I
Nope.
know it's
Yeah, that's how I memorize it. By doing questions.
negative b plus minus.
All over 2a.
And how would okay? So we know A, B, and C is because what? A
Mm-hmm.
no A is x squared, right?
Not x squared, the number in front of x squared.
1.
1. Very good. In this case.
B is 3.
Yes, ma'am.
And 2 is C.
Very good.
All right. Okay, now I get somewhere.
And that 4 is also constant in the equation, right?
That 4 is constant. That don't move.
I wonder how they get that far though.
If you have time, ask me that when we have time, and I'll show you. Like when we have time. Remember that. Remember to ask me when we have time. I can show you how they got that.
So as a rule of thumb, when when you have a variable in front of the, like you see how you have x squared.
Mm-hmm.
So when it's a variable, it'll always be one, right?
Yeah,
For a.
yeah, for A. So if you just have a variable and it's one. But sometimes it could be like say 2x, you know, or they can say 3x, you know. In that case, it would change, maybe, to whatever it is.
So it'd be three instead of.
One, yeah. So one. So are we done?
1 minute. Mr. Busy, how do you incorporate negative b?
Negative b. Well, b remains the same. Just put a negative in front of the number, whatever is b.
No, but I'm asking, how do you incorporate inside the equation?
Negative b.
Mm-hmm.
Oh, when you split it, that's when you could start to incorporate it. So when you split it into the negative b plus whatever you have here, and then the negative b minus whatever you have here, that's when you incorporate it.
Oh, okay, okay. So now I just have to split it then. Okay, that's what I meant.
Split it. You have to split it.
Okay, so negative 1
Um,
plus.
I have an answer, but I'm scared to say it.
And what's your answer?
I don't want to say it. I want to have a job.
Negative 1
They ain't ready yet.
minus. Oh, this thing's so complicated, God.
Okay, so when once you get your answer right, you can reduce it, like you can work it out from there,
You could reduce it. Yeah, you could reduce it for try see.
but it's not reducing. I don't
You're in it.
know.
That's it. You know, you haven't been able to do it.
I can
7
just say my
minus
answer. I don't
8.
care. I'm not good at math, so
Yeah,
I'm on your level. So do not laugh at me.
it's fine.
But laugh, that's good. I don't know how because even it will be dirty.
I have x equals -3 plus 10
Dear
squared.
God.
That's wrong.
Plus what?
Plus 10 squared over 2.
Mm-hmm. Plus two.
Yes, -3. I mean, x equals -3 plus 10 squared over 2. I don't know.
Hello.
And the next one.
No.
Oh, the next one.
Or it's plus or minus you have.
8.
Got it. I do the minus one.
Minus or just plus.
I do the plus one.
Okay, that's the plus one.
Minus 8. Hold on. I almost got it. Give me 1 minute. Divided by 2. Divided by 2. Okay. I got 0. And then I got negative 1.
So x is 0, and then x is -1. Okay. Anyone else? Anyone else? All right. So here we know that a is going to be what?
1.
Okay. B is going to be
3.
C is going to be
2.
2. Very good. So with that being said, it's going to be equal to, so x is going to be equal to negative b, which is what? 3 plus or minus the square root of b, which is what? 3.
Wait, that one? Where you put 3?
No, it's supposed to be 3 because
Oh my dear God.
it's 3. It can't be 1. How do you get 3? So it's going to be 3 squared minus 4. A is 1 and C is 2 divided by 2 times 1 because it's 2A. Good. Now x is going to be equal to negative 3 plus or minus the square root of 3 squared is 9.
6. Nope.
That's 9.
Nine.
Hello?
Mr. Petit?
Okay, 4 times.
Mr. Petit?
I was thinking about something, but we
Sorry, Mr. Petit?
I'm out.
I
You
want to
sure
change
we got
my.
enough space?
I can
Yeah.
change my answer, please.
What you gonna change your answer to?
-1 and -2.
Negative 1 and negative 2. Negative 1, negative 2.
My
-1 and 2.
2 or
Negative
negative 2?
-1 and 2.
Okay.
No, negative. No. Okay, never mind. It didn't there. Sorry, never
Negative
mind.
1 is here. Okay, so it's gonna be minus 8. Mr. Oli, she's gonna say something? Divided by 2. So
answer
it's
is negative as
x
well.
equal to negative 3 plus or minus. Um, I want us to be clear so I can see what's happening. Plus or minus the square root of 1, right? Because 9 minus 8 is 1, all divided by 2. So x is going to be equal to, sorry, so x is going to be equal to negative 3 plus or minus the square root of 1, I'm going to write it over, all divided by 2. So x is going to be equal to negative 3 plus or minus the square root of 1, the square root of 1,
1.
1, all divided by 2. So x positive is going to be equal to negative 3 plus 1
-3 plus 1
over
over
2
2.
plus 1. So it's going to be negative 2 over 2 is going to be equal to negative 1.
I got that.
So x negative is going to be equal to negative 3 minus 1 all over 2 is going to be negative 3 and negative 1 is negative 4 divided by 2 is going to be equal to negative 4 divided by
-2
negative 2. So your zeros are negative 1
and -2. I got that. First time. It makes sense.
Good. Any questions
I,
on
I almost had a miss with the gang, like.
algebra and computations? You gotta get a point for.
Any days you could send for homework. I don't mind practicing this a lot.
Sure, no problem. Um, example. Mm, like you always these are very nice ones, you know. I just gonna look for a regular worksheet online.
Miss Betty, when you finish, can you go back? Cause I don't know what I'm confused.
I want one that has answer key so that when you do it, you can actually see your answers one time. Okay, so they give you answer example law, practice, download this worksheet. I hope there's not a okay, I'm not a robot. Okay, I'm not a robot. Okay, that's good. Let's see. Okay, look, perfect, nice, good. Alright, and then they go on deep. Alright, that's when they run out. No. Okay, good. I like this. The reason why I like this is because they have different values for, like for example, for 6, notice that A is 2, right? And then for B is negative. I like that. So let's see. When we go to the bottom, let's see their numbers. Okay, that's good. That's good. That's good. Okay, so I want you to do number 1. Do number 1. You're gonna need number 1. I like the negatives there. Do number 2. You're gonna need that. And number 6. So number 1, number 2, number 6, and then number 16. Okay, so number 1, 2, 6, and 16. Let me send this PDF in the group. And now it's answers right there, so you can always um, check it once you're done. Let me also send it to myself just in case, um, you know, you missed it. Okay, good. It's 8:16 already? How? Oh, time flying. Let's see why we can't be parking on questions. But I'm glad that we going over and getting a chance to practice it though. Um,
Can you go back to the questions she's doing, please?
hopefully one thing you can notice from these things, it takes a while before you get a skill. You notice that? Like, that's why last minute can't work. You know what I mean? Like, you have to be working on this for a while, a while, a while. You know what I mean? Because um, it just takes a while to develop skill. That's just the nature of things. Amen. So when people say, "Oh,
When we do this, sorry, I even did I wait till you're done, sorry.
yeah," so when people say, "Oh, I'm gonna study one night," da, da, da. Oh, it ain't gonna happen. Maybe for social studies or bio or something like that. For maths, you have to had you know been putting in the work. You know. Go ahead, Auntie.
Do you want this homework sent to you?
Yeah, you can send it to me. Send it to me.
Cause I know you ain't marking it, so
Okay. But I want to see it to see how you set it up.
okay.
Um,
This
not
ain't due till next Sunday, right?
next Sunday. All right, let's put it until next Sunday. But
I don't know. It's up to. I don't know. It's used to use kind of the teacher, so I go by what you say.
I want you. I want. Well, tonight could be too early, so bring it in. Tuesday.
Tuesday.
Today is Lucifer.
Okay.
Okay.
Mr. Petit,
Yes, sir.
because this and record, right?
Yes, it is in recording.
So you want this.
You want it? Okay. No problem. No problem. I'll have to upload it tomorrow onto YouTube and send it. Okay, so next up. And if I don't send it tomorrow, please text me and say Mr. Petit, what's up, what's happening. So that I won't um so I will be on it. Okay, good. So that's this. Next up we have, but so far, how do you feel about this paper? We only on question number 8. How do you feel?
I think this one way different than that. 2019.
Okay, okay. In a good way?
Mm,
Yeah. Oh boy. Yeah. All right, let's go. Number 9.
I think paper three can be a headache, like the hardest paper to pass.
Like the thing is with paper 3 is that you use paper 3 to help you to move from B to A. So, and so try to get the most points you can, you know. Vectors, our favorite, hopefully.
Mr. Petit,
Uh-huh.
how much each paper weight? How much points are all?
That's a good question. Let me check and see. Um, so no, this what they say is how much. This one is out of 100. Paper 3. Yeah. Um, I think you mean it in terms of percentage. What are you trying to say? Or you mean how much like marks?
Yeah, like marks.
This one is out of 100 too. So paper 2 is out of 100 as well. And paper 1 should be out of 100. Let's see. Paper 1 should be out of. Yeah, it's out of 100 too. All of them out of 100. Alright. So, and I understand why they would use 100. It's just easier to mark when it's out of 100. Okay, good. We haven't done any paper 2 questions today. I hope you all straight with paper 2. I hope.
We need to do, Mr. Petit. I mean, I need that.
Yeah. Okay, so what are we doing? So let's do some vectors. E is the midpoint. That's a very important thing to remember. E is the midpoint of BC. AB is equal to Y, and EB is equal to Z, and DA is equal to X. Express in terms of X, Y, and Z. CB, DB, and CD. Okay, I'm going to give you all a few moments to look at that. I only need 60 seconds for that. That shouldn't be too much. So let me begin the timer. Let's go. Vectors. I gave you all a whole book for vectors.
For AB, I have AB plus
AB or CB?
for CB. I mean, as I started off,
Okay.
direction I go in.
Okay.
AB plus BC.
Now remember, we're looking at CB.
Yeah.
CB. So be careful. 25 seconds left. So it's time. What do we have for CB? Anyone? What do you have for CB?
Is it CD plus AB?
Remember, we just going from C to B, you know.
So the answer just would be C or some, right?
Say it again.
Never mind.
You close, Ricardo.
I was saying what the answer be C. C by itself.
Close. Very close.
Now you could talk. Sorry, my thing was tripping out, but I was going to say that we're going from C to E to B.
Very good. Very good.
So, I mean C to E, E to B. Sorry,
Yes, that's correct.
it just sorry. I was trying to get the answer, but the thing
Okay,
was
so
in it on me too.
what is the answer? It says it's not in terms of X and Y though, and Z. So give me your answer.
Can you go up so I could get the numbers?
You just need a diagram.
Wait, so but isn't it all that asked me to express in the terms?
So what is
Okay,
CB?
CB is Z.
Come on.
What do you mean by express in terms?
You told me that CB is moving from C to E, then E to B, right?
Yes, sir.
Good. So what is C to E, and what is E to B?
C to E.
That's the most important question.
I don't understand. Okay, I'm giving you the. I don't understand. Hold on. In
Okay,
terms, what do you mean by express in terms?
okay. Let me give you a hint. Do DB. That'll help you.
Okay, D to B is D. I mean B to Y, Y to A to X.
D
I
to B.
mean,
D to B. D to
oh,
B.
D to B. Okay, D to X, X to A to Y, Y to B.
No.
Wait,
It's the two.
is it D to A to B?
Yes, ma'am.
So why are we skipping the Y's?
Because this we're skipping X and Y because um that's not describing a point. X and Y are not points. X and Y is the vector. So D to A, the vector DA equals to X. Okay,
Oh,
maybe you do need to talk.
oh, so I would know that B to C is midpoint. So half. Um. Hold on, I am A to C and B to C. A to So is it Z and Z? Uh, no, I don't understand. It's super deep.
Anyone else? Any ideas?
For question B,
Yes, question B.
I have DA plus
Mm-hmm.
AB
Mm-hmm.
and X plus Y.
Very good. That's correct. That's correct. Good. Now give me CB.
Mm,
Now they gave us a mighty hint for CB. They told us that E is the midpoint.
that'll be E plus Z.
Would it be Z and then two Z?
Yes, ma'am.
That's the answer.
What the answer, Mr. D?
Wow.
Nancy, tell them.
Z plus 2z.
Not Z plus 2Z.
I mean 2z plus z. Sorry.
No,
Why?
it's just
Why,
2Z.
Mr. D?
It's just 2Z. Look,
Yeah, the clue was the midpoint. I forgot the clue. The clue was the midpoint.
see, CB is we going from C to E, and we going from E to B. Would you agree?
Yeah, I see it. All right.
Right. So we know from the question that E to B is Z. So this point E to B, that's Z. So Z is not referring from all the way from C to B. No. Z is referring from E to B. That's Z. But E is the midpoint. That means that E is the middle. So if this part is Z, this part also gonna be Z. Because if it's half, if E is half, right? If this is Z, this one also gonna be Z too. There's no choice but to be the same thing. Because they're gonna be equal. See what I'm saying?
I see it now.
Yeah. So if we're moving from C to E, what that's gonna be? What letter we
Gonna
gonna
be
use?
Z.
That's gonna be Z from C to E.
C to E is z.
And then from E to B is?
2z.
No. From E to B is
That's an
Z.
X.
Z and then X.
Yeah.
Very good. And so then all together we get what? Okay.
Okay, I look at so I don't know why I was tripping out then.
Now DB is exactly
CB.
what Ricardo said. We're gonna go from D to A, then A to B. So it's gonna be simply X plus Y.
Come on, let me get this back. Z plus C equals
Mr. Bethel, what happened? You all sleepy?
Mr. D.
2.
Yes, sir.
All right, I was in
Uh,
here when y'all do this.
Oh,
the videos you often go through with the vectors, they doing good.
they really help?
Yeah, yeah, that's how you think I got the thing on. I was like, hold on, I noticed. So
Yeah,
should be walking the path.
should be. Yeah.
Um, Probably because I am practice hard enough. You go down, please.
Okay, now we need CD. So CD is gonna be what?
That's B. So B stop at Y plus X.
You gotta think now. Oh yeah, that's about X plus Y.
Okay.
Okay, now for CD, how are we gonna get CD?
Um, you say CD. So we're going from C to E. So it's going to be Z plus Y plus Z. I mean plus X
No,
minus
you
Let me
said
give it a try.
minus you minusing because the you minusing Z from Y and X.
yes, ma'am. So it's
It,
gonna
it,
be
it's minus because of these. I think it's because of the arrows,
yes,
the
ma'am.
direction of the arrows.
Yes, ma'am. So because we're moving from because we say C to D, so we're trying to start from C going all the way to D. Okay, and so we're gonna move from C all the way to B because we could do that. We already know what CB is. That's 2Z. Okay, so it's gonna be 2Z, but then we're gonna subtract Y because we're going in the opposite direction. Okay, so for vectors, if you go in the opposite direction, you have to use a minus. Okay, and then we're gonna subtract X because we're going in the opposite direction of the vector. Okay, so altogether we'll have what? 2Z minus Y minus X. Okay, that's how it works. Again, 2Z.
So why with this one you want to use none of A, B, C, or D?
Um, I am just talking about it from the answer perspective. We can use that. So if I were to do it technically, right, this is how we would write it. Right, we'd say CD equals what? CB plus what? BD. Okay, and then we'd say CD equals what? CB. Same thing. We just bring that down. But this one is interesting because if we're going from B to D, right? We're going from B to D, right? That is the same thing as switching the endpoints and adding a negative. Okay, so that's what this means. So what we did here, and this is something very important to understand here with factors, right? So what we did here, right? Notice we're moving from B to D. That's what we want to do, right? Move from B to D. But that's the same thing as doing the opposite of going from D to B. Like think about that. Going from B to D is the opposite of going from D to B. That's why we add a negative. Okay? And so here we add a negative dB. But the negative dB is the same thing as positive BD. That's what it is. Okay? I don't know if you all understand that, but that's if we wanna switch the endpoints, the price of switching the endpoints is we have to add that negative. Okay, you can look at it like that. But we already know what dB is. Like dB is x plus y, right? So we just put that in there. But it's a negative x plus y. And so we distribute negative x, negative y. So we end up with 2z minus x minus y. So that's how we do it in the technical way.
Mr. Badi, can you scroll back up, please?
No problem. So what? A, B,
No, to the diagram,
yeah, no problem.
to the picture.
No problem.
So instead of going to C to E, you going straight to C to B.
Yeah, I'm going straight to C to B, right? Because we already know that. That's why they asked us to do it at the beginning.
So would it be wrong if like if I put C to E, to do it that way?
You wouldn't want to do that way because that's why they asked you to do C to B.
Oh,
Like you already conquer that. You ain't gotta do it again. You ain't gotta show that much progress.
Mr. Petit,
Yes, ma'am.
could you go down to the third part? I have a question
Mm-hmm.
concerning that. What I confused when you got past CD equals CB plus bracket negative DB. I understand that part, but everything afterwards, I'm confused.
You understand this part?
Yeah.
Good. All right. So, what is dB? Didn't we just find out what dB was?
Yeah.
X plus y, right?
Uh huh.
So we just put it in. Right?
So where did the 2Z came from the question before that?
No, the 2z is CB. Remember, CB is this. That's from C to B. So that's where the 2z come from.
Okay.
From here and then subtract that.
Okay.
Okay. And so it's gonna be negative x we distributed, and then negative y we
And
distributed.
then I see that you. So if it was a negative x and then I mean it was if it was a positive x and then a negative y, it will be plus x minus y.
Say it again. If it was a
Positive.
positive
Then in the bracket, then you'll put positive, right? Positive x, or you'll keep it as negative.
well, this negative over here have to be distributed to this x. That's why we have this negative.
Okay.
Negative have to be distributed to the y too.
And the reason that it's like that is because from the beginning, when you have negative dB, it's because you went in the opposite direction.
Yes, ma'am. Because it was
Oh, okay. I just want to understand. Thank you. It's different from the ones we did prior to this, though.
oh yeah. Come on, let me see.
No, the other ones we had were very simple compared to this one.
Let me look at this. I didn't see nothing there for me. Did you watch all the videos or?
Yes, you sent me a couple of videos where you was doing them, and then you sent me the answer sheet for all the ones in the book.
Yeah. And this was one. This was included in that.
Yes, it was. I just want to look familiar. Just practicing it,
Yeah.
different.
Okay. All right. That's factors. But I mean, this is the complicated way. Like we could easily figure the answer just by going 2z minus y minus x. And that's easy. You ain't gotta go through all that. That's just me being formal, right?
Oh, so you don't have to do all that.
No, you don't have to do all. That's just me being
Oh,
formal,
okay.
right? You can literally just go, okay, this is z, this is z, okay, 2z, good. All right, we go in an opposite direction, so this is gonna be negative y. Okay, we're going on that, the opposite direction, negative x. Boom, finish. All right, so you don't have to go through all that.
Okay.
I know, with Bethel, I ain't gotta tell him that twice. Right, Mr. Bethel?
All right. I was thinking of cutting this one as a loss, but now you say it that way, man.
Yeah,
Okay.
yeah. It's easy.
So there's 3 points they're giving you.
3 points. I just make it look hard with the notation, but because I have to be formal in writing it, right? But yeah, it's simple. I have to be formal because if my teacher catch me, um, it's something with my name on it, and it ain't formal, boy, she could get to me. They say no. The people who know, the people who know maths, they critics, bro. They critics. They critics, bro. So you gotta come correct. With the arrows, make sure you vectors up your arrows. Make sure you up the brackets. Make sure you up them stuff. Yeah. All right, number 10. We did this before. I just put it here. Um, you know, for because this was 2018 anyway, so I just following on to key. Hopefully, remember how to do this. The median is 45 because, well, 600 minus 600 divided by 2 gives us 300. And then when we do a correlation, we get that to be 45. So that's why that's the case. This line of a cricket.
And then you start with the quartiles.
And then they are only ask for the lower quartile this time. So the lower quartile is going to be, of course, 600 divided by 4, which is 150. Okay, and then when we do the correlation, I got 32. Okay, and then
You could zoom out of that so I could take a screenshot.
of the entire thing or what?
No, just the graph. So, because I can't draw right now, but if
Okay.
you could like zoom out a bit. All right, thank you. Let me take a quick screenshot.
And
All
then
right.
after that, we had to figure out what would be
Hold on, I take the screenshot. Yeah.
on the
All right. All right.
one moment. Let me fix it properly. Okay. Do it now.
Thank you.
So then we want the number of candidates who scored 40 or more. So if we look carefully, the ones who scored less than 40 was 240. Again, the ones who scored less than 40% was 240. Okay. So that means that the ones who scored more than 40 or equal to 40 is going to be 600 minus that 240 candidates, so it's 360. We did this. The only thing I would like to change is that I realized that for D, we had 70%. But when I did it more closely, I realized it's actually 70.5%. Because they say the pass mark if 90% are accepted. So that means that if it's out of 600, that means that if 90 were accepted, 510 was rejected. So what did they get? What percentage did they get such that they got rejected? Well, they got it's 510. When I did the correlation, it didn't fall exactly on. If you look carefully, if you look really close, it doesn't fall exactly on 70. Let me show you. Like it didn't fall exactly on 70. And so I was like, okay, that's 70.5. Because when I zoomed in some more, let me show what I mean. And this was horrible because zooming it in then wasn't nice. But I said, yeah, I'll have to go with 70.5 because this is This right here is 72 when I did it in the even spaces. This right here is 72. So if this is 72, 71 must be like right here in the middle of that. So this red can't be 71. So it have to be 70.5. Okay.
But would the examiners actually mark that hard though?
I don't know. Like I said, 71 can work on even 70, you know. Okay.
This bring me about the flashback we had around
Oh
two
yeah.
thirty.
That's why when I was doing it, I was like, oh man, this again. You know what I mean? Because I did this question today. I actually did this, wrote this thing today. So that's why, I was like, oh
You just get up early to do these kind of stuff.
man. Well, this question in particular I did today. And what else I did today? Do another question. I did the quadratic today and the vectors today. But some of them I did probably like on Friday. Um, yeah, on Friday.
So you didn't really rest this weekend then.
Well, Saturday I did rest a little bit.
Child, this is the life of a teacher. He can never be me.
I
This
know
is
what
life
you're
for a
doing.
business person.
I know business person.
No. This is the life of a teacher, man. All their life is exhausted. Like, no time for themselves but the summer. Child, not me.
You may think it's this is my hobby. I like it. I like
Yeah.
the
Many people who crazy do these kind of things.
no man, this is fun.
But something at least you like it.
Yeah, I honestly do like it. It's fun.
I never saw you complain. It's my teachers, them who I keep saying. It's be like, they don't pay me enough to do this. I'm not repeating myself. I'd be like, all right.
Yeah, something. Doing these questions is fun, honestly. So at least I get a kick out of
Miss Petit, could you just stop moving the screen for a minute, please?
it.
Why you do this to me, please? Just stay still, like you know my eyes in the best, man.
You still looking at this?
I
Anyway,
rebuke that. I rebuke that in the name of Jesus Christ. I have the 2020 vision. I can get the
the pass
2020
mark.
vision.
Only 90%, 90 candidates were accepted. So let
Hold
me see.
on, let me finish right that.
You still writing? We are writing. We taking screenshots. Who was writing?
Me, I have everything in my book already from
What?
the beginning.
No man. That's
You
why.
just didn't know because I wrote fast. Now my hands starting to get tired and everything's starting to fail.
We say
So
we ended at 10, right? That's what we say. 10, right?
no, sir.
I sure we said at 10, bro.
Mr. TV been here from 2 p.m. You will go until 10?
Nancy, you came here scrolling at 3:30. Don't come. Oh no.
That's a lie. No, 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 no. That's not true. Call me.
I have a witness.
The minute I get on my call and I was in. Mr. Baffler, what time did I come in class?
About 5 minutes to 3.
That's a run out.
Ah, this is nice. Give you that. But she wasn't too bad.
Yeah, I think like 3. I mean 2:40.
Okay.
Yes.
What time she called me? I can tell you right now. She did call me.
Going about my business, right on
When was it?
public,
Tell me.
live. Don't worry. One of these days when I go, you're all gonna miss me.
Nancy called at 2:43 p.m. All right.
And
Okay.
then remember, she didn't even come right away. She
No,
said
no,
she
no.
had to
Yeah.
finish walking to come.
Yeah. That's true.
I hop on at 2:45. Don't do that. Do not do that. Don't do that to me.
Okay, let's do this. Question number 11. I like this one. Pretty straightforward. The variables q and t are related, such that q is equal to 54 divided by 3 to the power of t. Calculate the value of q when t is equal to 0 and when t is equal to negative 2. So here they give us the value of t in each case. So this is just substitution. So when t is equal to 0, we have the following. We have q is equal to 54 divided by 3t. Remember, t is 0, so it's going to be 3 to the power of 0. But 3 to the power of 0 is 1. It's going to be 54 divided by 1, which is 54. That's why that's pretty straightforward one. And then we have when t is equal to negative 2. So when we have t is equal to negative 2, what happens is, what we do for this one is that we say, okay, well, substitute t for...
Mr. Petit, you're moving a little too fast. We go back to the top again.
That's what the screenshots we can, right?
No, I mean as in understanding you're moving too fast.
Oh, I'm moving fast? For real?
Yeah, I know. All I did is okay, two number B.
T is equal to 0. So just substitute the thing, right? That's all. So it's going to be 3 to the power of 0, right? Right?
Uh-huh.
And 3 to the power of 0 is 1. And then 54 divided by 1 is 54.
Okay, now you can move on, Mr. Petit.
After you finish writing, I understand. Okay. Um, this one, this one was a little interesting. But the idea is the same. We just substitute the negative 2. But pay attention to this, this part. So we have 3 to the power of negative 2. I could write that as 3 to the power of negative 1 times. All to the power of 2. That's the rule. So the rule says that if we have the 2 out in front, if we have the 2 out in front and all of this quantity here, so this stuff A, is to the power of something, then you could multiply the powers. Alright? So that's how we could get the negative 1 back. But I did in reverse. I said, okay, well, if this is negative 2, we could separate negative 2 as what? Negative 1 times 2. Okay, and so that's what I did here. And so that's the rule that I applied. And then I said, okay, well, okay. But from here, you could put this in your calculator. From here, you could put in your calculator. So you don't have to do these steps. Okay? But from here, you could just 54 divided by 3 to the power of negative 2. Put that in the calculator, and you'll get the answer.
What's the answer?
The answer is, what is 54 times 9? Whatever that is the answer.
24 divided.
Times 9. Yeah, 54 divided by 3 to the power of negative 2. That'll give you your answer directly. So you don't have to go through all that. You could do all of this. You could just put in the calculator. But I wanted to actually show what happens. So all I did was 3 to the power of negative 1 is 1 over 3. All squared, because the squared is still there. Then it's going to be 1 squared and 3 squared. Now 1 squared is 1, 3 squared is 9. So it's going to be 54 divided by 1 over 9. Okay. Now 1 over 9, 54 divided by 1 over 9. Since we're dividing fractions, it's going to be, flip it or multiply by the reciprocal. So it's going to be 54 divided by 1 times 9 over 1. So it's going to be 54 times 9, which is 486. So that's how we got the 486. But like I say, from your calculator, you could do it right from here and get your 486. Any questions on this? Comments or concerns?
So all I do was substitution and
That's all I was, the substitution.
so they giving us more free points.
Yes, essentially. 3 points for this. No, 2 points for that one. This one, B, is interesting, but B is substitution with a little bit algebra. So here our goal is to find the value of t when q equals to 2 over 3. So now here they didn't give us the value of t. They give us the value of q. And they want us to find what the value of t is. Okay, so again, q is equal to 54 divided by 3t. But what is q in this equation? What is q?
2/3.
2/3. Very good. It's gonna be 2/3. All right, is equal to 54 divided by 3 to the power of c. Okay. Now, what you think we're gonna do here? What do you think you get?
Cross multiply.
Cross multiply. So we're gonna multiply 3 by 2 and 3 by 2. All right. All right. So it's gonna be 3t times 2.
So you do that to get it out of fraction form then.
Yeah. Very good. I don't want no denominator. Okay. I don't want to be dealing with denominators. So it's gonna be 3 times 54. All I did is simplify it now. So it's gonna be 3 times 54 is 162. At this point, all we need to do is divide both sides by 2. Because I want the t by itself. Okay. So divide both sides by 2. I get, of course we're gonna cross these 2. So I'm left with simply 3t to the power of 162 divided by 2. Now 162 divided by 2, well, that's actually 81. So I'm left with 3t to the power of, 3t equals 81. But 81 can be written as 3 to the power of 4. Okay. And the rule says if you have the same base, the powers are equal. So we have the same base, so that means the powers are equal. So t equals 4.
So you can do that in any other way.
This is the easiest way. Any other way, we had do some log, ln. I didn't want to do. So I just do
But I mean, like the t, you can like take the tree away from the t somehow.
Oh, I understand. This is the problem, right? So this is the exponential to do. So this is not like 3x.
So we ain't have no inverse for that.
No, the inverse of what exponential is logarithm.
Oh, okay.
I have a question. Okay, my question is, how you got when you got A1? What is the quickest way to find like to make 81 3/4? You know what I mean? Like how? Let's say I have an equation like that, but I don't know how to turn my 81 into a like 3/4. How would I do that?
Oh, do you know?
Yeah, like how would I know how to do it?
Good question. The idea is that you know your base is gonna be 3. So that's a hint. Okay? And so what I did, all right? What I did, I can tell you what I did honestly. I don't know that 3 to the power of 4 is 81. I didn't know that. All I did on my calculator was, this one question I did today as well. All I did was I just said 3 to the power of, and I said, okay, let's try 2. Okay, 2 is 9, so that ain't gonna work. Okay, so let's try um, 3. Okay, 3 is 27, that ain't gonna work. Okay, so um, let's try 4. Okay, boom, it works. So it's 3 to the 4. Okay, so you know your base is gonna be 3, so that's a good end. So you start from 2 and go up, or you can start at 1, but starting at 1 will just give you the same thing. So yeah, that's how you do it.
Mr. Bade,
Yes, sir.
the cross multiplication, I thought you would multiply the 2 by 3t.
I did. So notice that this t is not at the bottom. This t is to the power. So it's not gonna be I'm not gonna say 6t because this is to the power is different. It's exponential. Okay, so we can't the most we could do is say 2 times 3t to the power of t. We can't simplify this further than that.
So if the 2 had a power, you would have multiplied then.
No, even if the 2 had the power, you couldn't do it. They're different. Now, if the t was to the bottom, like if the t was like, like the regular 3x of e or whatever,
Yeah.
then we could have multiplied the 2 by the 3 to get 6t. That would have worked. But this t is altogether different. We dealing with exponential function, so
All right.
it's to the power of it. So that's different.
Okay.
So if we don't know that last rule, we can't get this answer then.
Okay, if you don't know this last rule, then like I said, you could apply log. Okay, you just take the log of both sides and then do it like that. Okay, but the way the exam set up is that it's set up such that you don't have to use log because logarithm is not a part of your curriculum.
How you mean I could use log? How do I use that?
Well, I guess it's not a part of your syllabus, so
You don't recommend it.
I wouldn't recommend it because the most questions. This is the idea that they want you to use, honestly, right? For log, log is not necessary because what log would end up having you doing is um, um let's say we had 3t, right, equals to what, 81. The only good thing about log is that you don't have to figure out what is 81 what is this to the power of anything. You'll just say, okay, take the natural log of both sides. That's ln of 3t
I'm gonna put 81 in the calculator.
equal to
It's
ln
still ain't getting the thing, so
of 81. And then the rule is that um ln of a to the n is going to be equal to n times ln of a. That's the rule. And so this would go to the back. It's going to be t times ln of 3 is going to be equal to ln of 8. Then you divide both sides by ln of 3 ln of 3. And so t is going to be equal to ln of
8 or 81?
81. Thank you. So ln of 81 divided by ln of 3 is definitely, we get 4. Yeah, 4. So that's the ln of 80. You don't need to do this. Trust me. Just change this.
So if we don't hit in vice versa,
What?
if we don't need ln to do this, why would you need ln?
No. Because let's say if I give you something like say if I give you something like 2, 1, 4, I can't raise this to the power of 3 and get 214. There's nothing to the
Oh, because it'll be even number.
like, so use ln because ln is gonna give you something like t 4.23 whatever, such that you could be able to get this. You know what I mean? But you wouldn't
Okay.
know that off your head. You know what I mean? So it's not like a perfect whole number. Unlike when it's a perfect whole number, you could do that trick. You know what I mean? And so that's why for y'all, they don't use funny numbers. They just use a perfect one. So I knew it could have worked with a whole number. Right? Let me see if that's the last question. Oh, circle theorem, and then what else happens after this? And then it's bearing. So we're gonna continue this tomorrow because we gone into circle theorem, and then we gone into bearings. So hopefully tomorrow, I think tomorrow I'll have this completed. I can't wait. And so, because I stopped at number 13, I was like, man, I was like, wow, like, why did I only do up to number 13? We ain't got enough time. I mean, I thought that we would run through these and then, number 13, I'd have to do by hand, but we ain't even finished the ones I really do. So it's like, wow. Yeah, I thought we could have done multiple papers today, but we have to explain everything, and so that's important. So that's fine.
Oh, that's a good night.
Yes. We kill it today, though. We kill it today.
Yeah, today.
I went in on fumes. I had dinner yet, so I had engine. The
Wow,
last bit of engine left in me.
wow.
So
That food done cold, man.
yeah, boy, I gotta go to the microwave now.
Wow. Wait, I want to know who's still here. Who's the survivor? Who's still here?
I reach Mr. D. Mr. D,
Who's there? Who's
what
still there?
what equations say do again? What numbers?
Wait, one moment. One? You still there?
Hey, yeah, Mr. Petit.
Still there? How you feeling? After 4 hours. How much hours you slept? 4 hours? How you feeling?
You doing okay?
Hey,
Me and Bethel right now on empty gas tanks.
who is
Cause
that?
we've
All
been here
right.
from two. We've been here from two, man.
Oh, Alicia. Alicia still there?
Yes, sir.
How you feeling?
I'm okay.
Okay, okay, okay. And who else I have?
Honestly, I ain't tired enough.
Okay, okay.
I mean, I can go. I can finish going, Mr. D.
Say it again?
I can finish it off. We can finish it
Oh,
off.
finish it.
I just said.
No, we can stop it there in all deference. In all deference. We can leave
You
it.
wanna learn? I agree with him. I don't mind going, but let me
Yeah.
plug myself up to a machine, then come back.
Certainly. And then we meet tomorrow, so that's good. And so I'll see you all on
Let's see
tomorrow.
what equations they do again.
Say it again.
The equations, what all numbers you said do again?
Oh, that was one, two, um, 16,
And six.
6 and 16. Yeah, it's all right. When I see stuff like this, I just be like, wow, pretty. Like, I less like the structure of it. Just really look pretty, man.
Hey, Mr. Petit, I wanted to ask you
Go back
something.
on the place.
Wait, I gonna try finally find. One moment, Nancy.
We just was on it.
No, that was in the book. That was in
Oh,
the post. Wait, I have dollars. Where is my stuff?
I'm listening to the chat, you know. You could
Yeah,
open up the chat.
I just thought of that. I was like, why am I still looking for this? Putting this thing in the chat. Someone had a question? Okay. So it's 1, 2, 6, and 16. 1, 2, 6, and 16. Term quadratic equations. But we didn't encounter anything new tonight, eh? Except
Minimum.
the minimum, yeah.
yeah, the
Minimum.
maximum, minimum.
We yeah, that's a maximum minimum,
Yeah.
and the
Yeah.
area for some type new area.
Total surface area.
Yeah, the total surface area with the
We did this though.
LW,
We did it before,
VFW.
it just never sticked.
We did it before.
Yeah, we did it before.
Cumulative frequency was regular. Vectors was regular. Quadratic formula did revise. Um,
No, that one. I think this one is something.
yeah, this one is something
Yeah,
new.
this is new.
New, I wouldn't say new. We all know. We all been doing it. We only range from what? From
Yeah, we've been doing it, but like it's always been the equation, but never been this way.
yeah, I see what you're saying. Yeah, this is
Yeah.
just regular. Um, the scale factor. I don't think I've ever taught scale factor
No.
except for I did, with transformations, never with like with the area. So
So that is new as well.
this one is regular, man. It's just rearranging the equation, and so we should have known that.
The concept, we know the concept.
Area of a sector, yeah, we know that cross section area.
All right, folks. Mr.
Well,
D, I'd like to stick around, but I gotta go to bio now. So
oh, you have to go. Oh, last things, take care. Alright.
All right. Good night. Peace, everyone.
Good
Good night,
night.
everyone.
Mr. Petit, my question is
Yeah.
how okay, I'm reading books, right? But how do I incorporate all of the stuff I learned into the vocabulary thing you was talking about for English?
What books you reading?
I have a book collection.